It's our pleasure to invite you for our third plenary session. Today we have a mixed format for our conference, and we issue very interesting day of conference, interesting topics, interesting discussion, and interesting presentation. It's my pleasure to invite for first plenary lecture our colleagues from Poland, from Wrocław University of Science and Technology, Dr. Jarosław Szugiel. It's our pleasure. Thank you very much, Jarosław, for your visit and participation in our conference. Jarosław Szugiel holds PhD degree in computer engineering and worked as associate professor of Department of Computer Engineering, Wrocław University of Science and Technology, Poland. His research interests include programmable hardware, computer graphics and simulation, hardware implementation of cryptographic algorithms, and also numerical methods in maintenance and reliability analysis. And also author of over 60 papers and monograph chapters in these fields. He is also active in organizing committee of the International Conference of Dependability of Computer Systems, the post-real codex, which is organized by department every year since 2006. I think before such conference was, but I still can't. Yes, I can add that it's a beautiful conference, as the said. It's my pleasure to invite Dr. Jarosław Szugiel for his presentation, Challenges in FPGA Implementation of Cryptographic Algorithms, a case study of evolution in Blake hash function. Welcome, Jarosław.
Thank you very much, Professor. I should be connected right now. Everything is seen and heard, I hope.
Yes.
Thank you very much for this nice introduction. Let me, first of all, let me allow to make this presentation sitting, because in this way I will be seen through the camera to everybody online. So before I start, let me invite you all to our conference. As Professor Kaczenko has already said, we have our series of conferences, DEPCO through COMEX. Next year, at the beginning of July, we will be celebrating, we can say, 20th edition of this conference. It is held in Brunów Palace, about 100 kilometers out of Wrocław, but we provide bus transportation, we provide all accommodation, full meals, social programs, so we take care of the participants throughout all these days. So you are cordially invited. If you need some info, you can also ask Professor Kaczenko, who is our honorable guest. Okay, now let's go back to my presentation. I will talk about, first of all, a few words about Blake algorithm, because this is a case study of FPGA implementation of this particular hash function. And then I will concentrate on two issues which arise in those implementations: size problems and power consumption. So it will be a very practical approach. It will be a case study. What are the challenges a designer may face when he or she tries to implement a cryptographic algorithm in hardware in general and in FPGA device in particular? So a brief introduction, because this is not a cryptologist conference. Hash functions are very common in computer science. In general, hash function takes message of any length n and produces so-called digest or hash, simply hash value, which identifies this message. And in cryptography, we have particular application because in general hash functions are used, for example, for data organization, data structures, hashing tables. But in cryptography, we want to have the hash function difficult to be broken. Okay, so for any specific hash, it should be very difficult. It should be particularly impossible to find a message which produces such a hash value. This is a pre-image task. On the other hand, having one message M1, it should be very difficult to find another message M2, such that we have identical hashes of both those messages. Of course, the hashes in cryptography are long. They are very big values, for example, 265 bits or half kilobits or even more. Hashes are ubiquitous in cryptography, actually. They can be found in any cryptography message, in message authentication, data identification, in digital watermarking, actually from good hash functions. Good hash function, you can make a symmetric block cipher, stream cipher, whatever. So hashes has been, first methods have been introduced very early. Mr. Ronald Rivers from MIT proposed so-called message digest algorithms already in the 80s, and they create the foundation for first recommendations of Internet Society, so-called MD 245 methods, which were published in these years, 89, 92. And soon there was an official SHA-1 standard. SHA stands for Secure Hash Algorithm, which was based on Mr. Rivers' developments. This first standard was slightly amended, extended in 2002, but it was obsolete by this year. And in 2007, National Institute of Standards and Technology announced an open contest for SHA-3, the contemporary, modern, and strong enough hash algorithm. There were 5 finalists. Alphabetically, the first one was our Blake algorithm. It was not a winner of this competition. Okay, sorry. So in 2012, actually Ketchak was announced as the winner. Some problems with microphones. Too many microphones. We have too many microphones here.
It's necessary to disable sound, but not the microphone.
Okay. Sorry for this technical problems. So the winner of the contest was another algorithm, Ketchak. I will make some comparisons here. But the Blake was and is still quite popular because it is very fast in software. It is significantly faster than Ketchak. And actually, cryptographers, those dealing with software implementations, do not like SHA-3 standard because it is slow. It is very strong. It is very safe and secure, but in software, it is slow. Blake is much faster, and therefore it is used, for example, in archive formats, in Linux kernel, you can find in key derivation functions, etc., etc. So this is not a dead project, although it originated a long time ago and it was not a winner of the contest. In 2013, the authors proposed the second version, Blake 2, and 2020, quite recently, the latest modification, Blake 3, appeared. So it's still used and it's still alive. Okay, briefly about the structure of this algorithm, because we will be implementing this in hardware. The message first is divided into half kilobits blocks, and each block is first hashed, and then the result of the hashes is used as the input for the next block hashing. So this is typical chain sequential hashing, nothing specific here. But the essence of the method is this compress function. This is where the actual hashing is done, and implementation of this compress function is the subject of my work. I will present FPGA implementation of this compress function without talking about the infrastructure which is around. It is of secondary importance. The compression function consists of 14 rounds. This is also a typical approach in any cryptographic algorithm. we define one round as a set of transformation, and we repeat this round as many times as is needed for sufficient cryptographic strength. In Blake, we have state. This is a path of the so-called state bits, which is half kilobit, 512 bits. The state is composed of, this is the input hash value, and two other parameters, this is a salt and counter, these are secondary. But first of all, we have input hash value, this is the same as here. And this is the path of the state. The state goes through 14 rounds in sequence. The rounds are identical, but also the rounds use the message. Okay, so this is the message which is loaded as a second input to the compression function. And this message constitutes a parallel path of data, which must be provided to all round instances. This is a block diagram of Blake processing, and actually this could be treated as one implementation of this algorithm in hardware. We just make instances of all rounds in hardware, but this is a very expensive approach because we need a lot of silicon for 14 instances of the round. So in general, as a side remark, round-based ciphers are common in cryptography, and in general, we can implement them in hardware, first of all, in typical iterative architecture, which will be denoted as X1 here. We implement in the hardware in silicon just one round, and the state goes through the round as many times as there are rounds. In our case of Blake, 14 clock cycles, 14 times the message, and the state must go through the round. This is a standard iterative, the simplest approach, just like in the software. In software, we never repeat the same code of round 14 times or whatever times, one after another. We organize simple loop. In hardware, we can implement this standard iterative approach, but also we can unroll the loop, for example, placing k instances of rounds in hardware, and we need less clock cycles to complete the compression. And another technique is pipelining, where we introduce registers between parts of combinational paths. We split the combinational paths into pipeline segments. In this way, we load multiple parallel streams of data to those registers, and we have parallel processing. This is the fundamental benefit of pipelining. We increase the throughput because we process many chunks of data parallel concurrently, and we increase the throughput. This is how those architecture will be denoted here. If we have standard iterative with pipelining architecture, we will omit this X1 symbol. Okay, now let's return to the Blake round. The round itself is quite regular in Blake. It consists of 8 instances of so-called G function. The G function is finally the lowest level part of the algorithm. The state consists of 16 32-bit words because we have 512 half kilobits, so 16 32-bit words. 4 bits go to each instance. We need 4 G function in parallel processing the state for the first time, and in the same round after just reordering of the second processing in the second set. So we have 8 G functions in each round. And this is the last bit of definition of the cipher. Each G function is defined in the specification as a set of these equations. It's defined algebraically. This is a sequence of operation which should be done on the 4 input words VA up to VD. And when we transform these equations into data paths, which is something found in the hardware, in the silicon later, we get this diagram, something like this. What are the elementary transformations in this cipher. This cipher uses extensively additions. This is 32-bit addition. We take two vectors, add them arithmetically. We ignore carry out. Carry out is unimportant here. We just add these two vectors. We also have XOR, bitwise XOR operation. We take two vectors and XOR bit by bit. This is simpler than addition because we do not have carry propagation. It's faster and simpler. We also have some constants, okay? V, these are state messages, state words, sorry. M, these are message words. C, these are constants defined in the standard. And also we have the last third elementary transformation, we have rotations by a constant number of bits. We have 32-bit vector, we rotate it to the right by 16, 12, 8, or 7 bits. And all these operations constitute in silicon one instance of a G function, okay? Oh, I don't know. This is not here. Is it all? One point which is worth noting here, message words are taken in specific permutations. Sigma is a permutation defined in the standard, in the specification. In each round, we take different permutation of the words, message words, which are loaded here. Okay, what was the evolution?
Sorry.
In message path initialization, etc., which are unimportant for us. In Blake 3 in 2020, they first of all replaced the simple sequential chain hashing with tree hashing, which is very important for parallel processing of chunks of the message, of the long file, for example. We divide it into 3 nodes, and then we can hash them in parallel. But it is also out of the compression function. Then the number of runs was further reduced to 7. But what is actually very important for us, permutations were removed from specifications. So here we see, here in this place, we see just a constant number of, as an index of the message instead of permutation. In place of the permutation, the message words are permuted after each round. So instead of permuting the words at the inputs of the G functions, we permute them out of the G functions after each round. And some other minor simplifications. Okay, so this is in brief presentation of the algorithm. Now, I made a sequence of papers about problems which arise in hardware implementations of these methods. What's the problem with message distribution in Blake 2 first? Then we will turn our attention to Blake 3. In Blake 2, first of all, most of the hashes, other hashes, including SHA-3 standard Ketchak, do not require separate path for the message. The message in virtually all other algorithms is loaded as an input to the round at the beginning, and then it can be discarded, it can be forgotten. In Blake, we need to remember the message because each round will use the message. In pipelining, it creates additional problems because we have to add additional registers, we have to divide the message path also to the pipeline stages we must synchronize. So this is a little bit complex. But the biggest problem is with these permutations, sigma permutations of the words, because all the message words which goes into the round must be selected dynamically at the input of the G functions, depending on the round number, depending on the specific permutation. In hardware, this means that we must implement 16:1 multiplexers, because we have 16 words on the input, just one output. All these signals are 32-bit signals. In all the round, we need 16 maxes, multiplexers, and their combined input is 8 kilobits. So we have half kilobit of data here, half kilobit of data here. This is the size of this hardware. And total width of those multiplexers is 8 kilobit. So this is a lot of hardware. Just to implement such a detail of the specification, multiplexing of the words, permuting the words dynamically inside the round. For each round number, we must use different permutation. Because this is dynamic permutation, then we have to use all those multiplexers. Already in 2017, I didn't like these multiplexers, so I had some thoughts that maybe it will be better to replace those multiplexers, for example, with dual block RAM memories, which are available in FPGA devices. Instead of those multiplexers, we need to load all message words into this RAM. So this is costly, it costs time. We need extra initialization time. But later on, we do not have any multiplexers. We remove those multiplexers at all, and we just address this RAM. Dual block port memories, it was a very fortunate coincidence because in FPGAs we have dual port RAM, so we can address the same RAM block with 2 outputs, not 3, not 4, but 2. And this is exactly what is needed for this application. So this is very fortunate coincidence, because without dual port functionality, we will not be able to use this approach. This is rather academic discussion, because in practical applications, I think no one would allow for this extra clock ticks for loading the memory with data. It is possible if speed is not our problem, but it is a little bit strange approach. It is rather academic consideration. But the results were simply, I was very amazed even by the effects, because the size of these modified implementations were reduced by half compared to the original approach. So it turned out that this one detail of the specification, that we have to multiplex dynamically words in each round, it costs half of the hardware in implementation of the method. This graph presents in percent sizes, expresses in lookup tables. These are function generators in FPGAs. So this is a good measure of how many function generators in FPGA we need for implementation of the message. And as we can see in Blake, we reduce them to about 50%. In Blake 2, we reduce them even further to 45%, let's say. So this is, the reduction is over twofold. So the cryptographers came up with such a nice algorithm defined in all those equations, and it turned out that the message multiplexer, which was required in those equations, costed half of the hardware. If we remove it, we get such a big improvement. Actually, there was also some improvement in clock period, but it was not as spectacular. But obviously, when you have a smaller hardware, we have also faster hardware. So the reductions were up to 20%, let's say. in clock period, so we also get faster hardware. Okay, so after introduction of Blake 3, I was very, let's say, happy to see that in their specification they removed those multiplexers. Instead, each G function gets the same 2 consecutive message words. We do not have those multiplexing. We have constant connections between message words and the functions, the modules. Instead, as it was noted, we must change the order of the words between each round, but this is just a permutation. Permutation in hardware is actually for free because we do it exclusively in routing. We change the roots of the signals and that's it. So permutation does not need any logic resources, any functions, generators, lookup tables, LUTs. And as expected, it also resulted in high reductions in size, but now we are talking just about regular implementation. Blake 3 versus Blake 2 is 32% smaller, a little bit less than half, but still it is smaller, and about 50% faster. This graph also compares the size and speed against Ketchup, against SHA-3 standard. On the left-hand side, we have clock period, so the lower the better, the faster. In the right-hand side, we have size. And here we can see that Ketchup was quite large in hardware. It was larger than original Blake 2, and now it is much larger than Blake 3. But as far as speed is concerned, the Ketchup is very fast in hardware. It has very efficient hardware implementation because we have very short clock periods. Now the differences with Blake 3, now the difference is a little bit less. So now finally we can say that Blake 3 is still much slower than SHA-3, but at least it is by 50% roughly smaller. So this is some sort of advantage. Okay, let me move on to. Oops, sorry. Let me move to the last point of my presentation: power analysis. I will be talking here about pipelined architectures of Blake 3 because we are talking about speed here, first of all, and I will compare it with Blake 2 and Ketchup, but in the standard iterative organization, so these 3 actually are comparable among themselves. These architectures, this is extra case of high throughput Blake 3 implementations. When I looked at the power parameters, this was another surprise for me apart from those sizes, because it turned out that the Blake is very power hungry method. Very power-hungry method compared to Ketchup period. Here, no other comparison is done. The left-hand graph presents proportionality factor because in contemporary CMOS devices, we have almost linear dependency between clock frequency and power. And this parameter is just a proportionality factor, milliwatts per megahertz. The second right-hand side parameter is better for comparison because it tells you about cryptographic cost. This parameter is total energy consumed by single hash calculation. If we have this proportionality, if the power is connected linearly with clock frequency, then we, knowing how many clock cycles are needed for single hash computation, we can also compute this metric, EH. It is microjoules per single hash. And here we can compare everything. First of all, please note that this is logarithmic scale, because the distribution is so wide that in linear scale we will not see much in this graph, because the first value for unpipelined, for purely iterative architectures, the parameters are very high, 250 down to 10 milliwatts per megahertz in P2 architecture. So we can see that Blake-free variants demonstrate huge power reductions with pipelining. When we switch from X1, from iterative unpipelined architecture to the 2 stages of pipeline, we reduce the power to 4.5%. This is 20 times the reduction of power. When we divide the logic into further pipeline stages, more pipeline stages, when we move from P2 to P4, we reduce the power to 28% and then to 76%. So obviously, there's a saturation with the pipeline length. But first of all, the X1 organization, unpipelined, is very power hungry, is very power inefficient. In Ketchak, we have this parameter 0.2. So this is, let's say, 5 times or even more. But this is mainly, because Ketchak requires much more rounds. If we compare this parameter, this characteristic, these values, we can see about 20. The difference between raw power consumption depending just on clock speed. Okay, so pipelining turns out to be a method of power reduction as a side effect, and this is well-known effect in digital hardware. First of all, we apply pipelining to increase the throughput, the speed of data transformations, but as a side effect, pipelining quite often reduces power because it reduces number of transitions per clock periods in signals. In the ideal operation, when a digital circuit needs to compute a new value, we imagine that the, for example, single bit just turns from 0 to 1. It switches from 0 to 1, and that's it. But in real hardware, there's lots of, sometimes there are oscillations in those in the switching. So it goes from 0 to 1, back to 0, etc., 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 many times until the final value is stable. Those transients are called glitches, and they are typical to complex involved combinatorial circuits. In Blake, the number of glitches, the number of transitions per clock period is very high. Over 1,300 glitches in top 5% most active signals, because obviously in the design we have lots of signals, thousands, hundreds of thousands signals. If we look at those which are connected with actual hash computation, we select 5% of most active signals, and we average the number of transitions. These are the numbers of this graph. And as we can see, adding 2 stages of pipeline reduce this 1,300 to just 48 transitions per clock period. In Ketchak, we have just 10 transitions. So this is very nice behavior, very stable behavior, taking into account that we are talking about cryptography, so we have very complex combinatorial transformations. In Blake, we need four pipeline stages to get to the level of Ketchak, SHA-3 standard. Having seen this result, I came with my last point of my presentation. This was actually the paper from this year, which I'm preparing to publish in a journal. What if we replace these summation circuits with dedicated others, which are in FPGA array in DSP slices? DSP slice is a resource located outside of the programmable array. So we have a FPGA array, the classic standard one, with logic cells, with lookup table generators, with flip-flops. And besides this array, we have, first of all, block memories and also DSP slices. DSP slices, as the name says, were made for digital signal processing. They are very efficient in fast computations of multiply and accumulate calculations. And these calculations are the foundation of all DSP algorithms. In Blake, we have two, in each G function instance, we have two free input others and two input others, as we can see. For our purposes, we need to configure DSP slice in a very trivial way because inside DSP slice, we have very complex pre-processing logic capable of scaling, of pre-adding, etc. This is all needed for DSP algorithms. But what we need actually is this arithmetic logic unit, which can be programmed into a number of functions. We need just addition. And this all is done on 38-bit. We need just 32 bits for Blake words. So we do not use all this complex logic. We just use others. And we configure two input other or three input other by joining into cascade to adjacent DSP slices. In total, we need 48 DSP elements for one Blake round. This is a substantial amount. If we look at the changes in size and speed with DSP elements, this is the graph which shows those changes. As we can see, first of all, we see very high reductions in lookup tables, in function generators by minus 33, 37%. Obviously, because now lookup tables are not used for summations, the others are in the DSP elements. But what we see is that there is no reduction in slices, actually. Slight increases we can see. Slices are the nodes of the programmable array. Every slice
Sorry. Чекаємо. Cool.
I think.
Yes,
Am I back?
you're back. Visible. We need to share the
Mm-hmm.
screen.
Okay.
Maybe
must-
this one, yes, this one.
Mm-hmm.
Okay, so it's back one.
Mm-hmm.
Now it's stopped again. No, you have stopped again the sharing. You need to share
Really?
again.
Okay. What was that? Okay. Okay.
Okay, now it's okay.
Am I back
Yes,
online?
You can see, yes.
Yes, please continue.
Okay, so the question is, how many slides did you miss? Sorry. Okay, so on this slide, I was talking about the reductions which were made by application of DSP elements. The reductions is lookup tables, but deterioration of Fmax. And this slide was about the reductions, very good reductions in signal glitches. And this slide summarizes the effects of the application of DSP elements. As we can see, we have very efficient and nice reduction in power per energy per hash value in these two first architectures, but in case of pipeline architecture, we do not any improvement. Instead, we see deterioration. This is because DSP elements are quite power hungry. They dissipate a lot of power. And if this extra power is too high, then we do not see any improvement. This is clearly seen in this chart because it shows that the logic component, which includes DSP, in highly pipelined organization is actually higher than the original one without DSP slices. This is the effect of high power demand of DSP slices. DSP slices are optimized for speed of computation, first of all, not for low power consumption. Okay, to conclude, because it's time for conclusions. This was a case study. Cryptographic algorithms are very specific algorithms. They have very involved, complicated internal structure. And their hardware implementation is always a problem because you get a very complex gate network which must be efficiently routed, etc., etc. In Blake 2, first of all, there were problems with specific message distribution. This was just one of the features in specification, but it had very bad consequences for size. Much better approach was introduced in Blake 3. But on the other hand, the Blake transformations are built on 32-bit adders, summation circuits. And these introduce a lot of glitches. They were introduced for cryptographic avalanche. Avalanche effect is very good for cryptographic strength, but it was a nightmare for signal stability and power consumption. Pipelining turned out to be obligatory just for power reduction, not for increasing the throughput, not necessarily, but just for power reduction. Or you can use also dedicated DSP slices as an alternative in unpipelined cases, at least, because in pipelined cases, there's no point in using DSP slices. This would be the summary of my presentation, but actually there's one important question, because I was not talking about cryptology, about cryptography. The basic question here is how to assess the cryptographic merit of all those modifications which were introduced in the cipher. Because we know that some solutions are very costly in hardware, we can replace them with our solution by introducing notification. But how does it change the strength of the cipher? This is the basic question. But the problem is that even cryptologists cannot agree about how to evaluate, how to assess cryptographic strength of specific algorithm, or specific parts of the algorithm. There are ongoing discussion which approach is better. There is no strict benchmark, let's say, which would allow to evaluate those parameters. And there's lots of discussion. At the end of discussion, the experts must vote because they cannot agree in any formal way. So this question remains open, but it is out of the scope of my presentation. Thank you. This will be all.
Thank you. Now we have short time for question and answer. Let's start with our question online. Artem Pereplisov, welcome.
Thank you for your really interesting report, and it's fantastic and extremely interesting for me because it's exactly that I'm doing and I did and implemented. So it's really interesting to see the Black 2 and the usage of DSP and the power analysis. But there are a few questions and comments, if you will allow. The first one is you considered the round-based implementation of cryptographic algorithms and considered the possibility of pipelining and some standard implementation like it was in software. But did you consider the mixed version while it's possible to pipeline some part of the catch-up algorithm and at the same time to create some number of instances to balance it inside the FPGA? I mean, to balance the resources. For example, if we need to obtain the result of catch-up computations during 15 clock cycles, it's possible to use some number of pipeline rounds. If less, it's possible to add more, and so on. So the question: did you consider the possibility of mixing round-based pipelining and direct parallel implementation? This is the first question.
Okay, thank you very much for this question. It's an interesting topic. No, I have not done any studies, not yet, about this mixed approach. But you are perfectly right. If we can see that something is good in unpipelined way, and something is good in pipeline, we can try to mix. I haven't tried this, but it could be an interesting direction for optimizations. Yes.
Thank you. It's interesting because it allows to parameterize the resources. So depending on the available resources and requires to intensity of results, it's possible to use different combinations without a redesign of the code. Another question. You provided the possibility of optimization with DSP blocks. I assume that you are using Xilinx ultra-scale chips because of 48 bits of DSP. And they provide an ability to use 3 input adders based on single DSP slice because it's possible to use the carry input, parallel carry input, and it's possible to obtain 3 in adders. And
these others but these others must operate on 32-bit arguments. I think the path you are talking about is not this wide.
It's necessary to check it because it was already implemented in this way. And it's also interesting that it's possible to use such 48-bit DSP blocks to implement also XOR operations, wide XOR, and multiplexers if it's necessary to reach the dramatic fast computations. And this is the last question. You provided information about the power consumption dependent on the frequency, but you not specify the exact frequencies that were used and the amount of the resources per crystal. I mean the percentage. It's also interesting because the power consumption also depends on the percent of the usage of all the resources of exact chip. So maybe it's necessary to take it into account. I mean, add the information about the exact frequency. What is it? 200 megahertz, 300, or up to 500, theoretically possible. So it's really interesting to realize the exact results of the power consumption.
Okay, I didn't include all the details in my presentation, of course, but if you are interested, I have a full reports which are provided in the bibliography of my paper. In my paper, I can't remember, maybe I didn't include specific results regarding maximum. Oh no, there's a table in my paper which will be published, I think. So you will see in the table maximal frequencies of all those architectures. If you are even more interested, you can look into my bibliography positions. What you are talking about the SP elements, yes, of course, it will be another interesting direction for further optimization. You can also use the SP elements for different operations. Yes, but my point first, as the first step of the study, was to just compare the previous approach with this approach, which could be further optimized. Yes.
Thank you. Really interesting, and I think that it's necessary to check your publication. Thank you.
Yes.
Thank you. Thank you so much. Sorry we had not enough time for continue the discussion. Thank you, Dr.
Thank you.
Yaroslav, for your.
Thank you once again for inviting me. This was a pleasure.
Thank you. Thank you. Okay, let's continue our plenary session, and it's my pleasure to invite for next keynote lecture, Professor Elena.
Please wait.
Okay. Can you hear us?
Now, yes.
Put your microphone. No,
About presentation, Okay.
Dear colleagues, do you hear and see presentation?
Yes.
Okay. It's my pleasure to invite for keynote lecture Professor Елена Зайцева, University of Žilina, the Slovak Republic. Professor Елена Зайцева works at the Department of Informatics of the University of Žilina, the Slovak Republic. His research interests include mathematical methods in reliability and safety analysis, classification problem, and algebra logic-based methods application in reliability evaluation of complex systems. She is author of more than 100 articles. She has led international and national projects practically related to reliability analysis and its use in applications such as information technology, healthcare, and ecology. She is a member of Technical Committee of European Safety and Reliability Association and the chair of Reliability Association.
One second.
Okay. Sorry for some technical problem. This situation illustrates that really we need to consider is not only system in as binary systems that work or fall. In this situation, we can we should be consider a system as multi-state, because between complete fault and complete function there is some state, and we can improve situation for system reliability, analyze the situation if used multi-state system. And if we consider multi-state system, we need to decide how we can present it, this system mathematically. There are some methods, some representation, mathematical representation for multi-state system. And there are some methods which allow us investigate system based of multi-state system as mathematical model. Of course, it's extension of binary models for case of multi-state system. It's a stochastic process which are adopted and used for multi-state system analysis. First of all, it's a Markov model. And next is a universal generation function, very often used for analysis of multi-state system, Monte Carlo simulation, Bayesian model, etc., etc., etc. All method of mathematical representation used for binary state system plus or minus can be used for multi-state system. But we propose used for analysis of multi-state system extension of binary model to a multi-state system, multi-state system case. Between all of this extension, we first of all consider mathematical representation of system based of structure function. Structure function have closely correlation with decision diagram, algebra logica based method, reliability block diagram, multi-state diagram, and other. But first of all, if we say about all of this representation of structure function, we need understand what is this structure function, how we can present it, this mathematical model. If we consider on a structure function or definition of structure function, its function can be defined by this mathematical expression. This expression maps all combination of component state to system state. For more exact definition of conception, we say that component have state and system have performance level. So we can consider the structure function as maps of all combination of component state to performance level of system. And if we want to consider multi-state system, and we say that it will be considered as extension of Boolean method, we need to decide next problem, the problem of dimensional, because if we used more large system for more detailed representation of system, is as rule extend the dimensional of mathematical model. We need new method, new algorithm for evaluation and computation of indices for reliability, and we need designed problem of uncertainty. About this problem, I say somewhat, especially in this presentation. If we say about first two of this problem is problem of dimensional of multi-state system, and needs to develop new method and algorithm for analysis of system based of multi-state system. We don't have to use Boolean method, and we can be able for this problem other method. It's method of multi-evaluate logic. Typically, in reliability analysis for multi-stage system used Boolean method, but it's not effective, and more effective used multi-evaluate logic method. And if we want to consider the problem of uncertainty of data in a multi-stage system, we should use machine learning methods. So all principal problem which there are in application of multi-stage system, we can decide based of multi-evaluate logic and some of method of machine learning. Let me introduce more detail this problem and illustrate what mean problem, for example, in interpretation application of multi-state system for reliability analysis. In this slide, we can see a very simple system. It's parallel system of two components. If we will use the binary state system, it's our first table. In this case, we have only one representation of this system. It's very well now Boolean function or. But if we will consider multi-state system, we have numerous representation, mathematical representation of this system. The two first table illustrate that we can indicate different number for component state. In the first table, we have only two state for component. In the second table, we have for second component three state. It's different mathematical model in different result in point of view or reliability analysis. And last two table have a similar number of state for component, but it's different mathematical representation in different system in point of view of reliability, because functioning of this case is defined by a different way. It's the first problem which we need to decide with application of multi-stage system. So it means that it's not enough only define typical structure as, for example, serial parallel system. We need exact defined mathematical description of system in terms of multi-state system. But previously, I say that for analysis of multi-state system, we can use method of multiple evaluate logic. Of course, it's possible, but we need to decide before this application a very important theoretical problem. If we consider structural function of multi-state system, it's, for example, you can see example in which the first component have two states, the second component have three states, and system have three states in its behavior. But can we such function interpreted as a multi-state system? Typically is not because definition of multiple evaluate logic you can see which defined by this expression. What the principal difference between structural function and multiple evaluate logic? Principal difference that in a multiple evaluate logic we have equal number of value for all variable and value of function. In structural function is not necessary, and it should be decided. To decide that problem, we can introduce for in point of view of theoretical aspect, we can introduce is not a specific state for our structural function. It's we consider such function in term of multiple evaluate logic. This function can be interpreted as multiple evaluate logic. It means that all methods that can be used for multiple evaluate logic can be used for analysis of structure function. So problem that correlation between multiple evaluate logic function and structure function can be decided, and we can use all methods from multiple evaluate logic to analysis of multi-stage system in reliability analysis. But next question, next problem, what need consider. It's a problem that how we can propose interpretation of structure function which we used. Previously, in previous slide, it was indicated as table definition or analytical definition, but there are one more interpretation of structure function. It's very important for application in definition, for application method from machine learning, for definition problem of uncertainty in data for development structure function. Is interpretation of structure function by classification structure. It's really, if we consider this table which presented in this slide, and one interpretation of structure function, but we can present it this structure function as a classifier which divided all state into in three classes. One class is 0. It's agree with state when system fall. The second class is marked but 1 in state when system have some functioning, and last class is state for perfect functioning of our system. So if we have some uncertainty, for example, in our system, for example, we have no definition for two state. How we classify and indicate the state for a description investigated system by multi-state system or other mathematical model, we need interpreted this state by some of method. Of course, here we can end in other type of uncertainty. Is not only incompletely specified type, but it can be introduced the uncertainty as vagueness ambiguity, which don't allow us exact indicate that this state is perfect functioning or partly functioning. It's Bodin definition in interpretation of system state. To cover this problem of ascendantly interpreted ascendantly in term of mathematical model of multi-state system, we need to introduce some correlation between classifier induction and conception of reliability analysis if our system represented by multi-state system or structure function. In this table, it's indicated this correlation. In this table, we can indicate the number of components system can be interpreted as number of input attribute. System component can be interpreted as input attribute for induction of classifier. The system performance level is interpreted as target attribute or output attribute, and values of this is attributed, we can interpret it as component state or system performance level. And generally, structure function, we can interpret it as a decision table which can be elaborated based of any of classifier. The typical typical method for development of structural function or mathematical model in form of structural function for multi-state system, we can present it by 3 steps. The first step is data collection. We need to collect data. It's can be observation or expert evaluation, and based on this data, we form a data set which is acceptable for classifier induction or classifier development. Second step is
Sorry, we know you lost the image for a point, but did you also lose the sound? Dear colleagues online? Can you hear us online?
Yes, we can hear you.
Yes.
Did you lose the sound for a period or just the picture?
okay. Let me continue. Do you hear? Do you see the share screen?
Yes,
Okay.
please.
Okay, let me introduce some example of application of proposed approach for reliability analysis system by application of multi-state system as mathematical model and taking into account the assessment which we decided by method of machine learning. For example, we have drone fleet, drone swarm, and we have only some observation for about this problem. Only for some drone we have defined it as state that functioning or no, and loss state were added by expert evaluation. So for each state in this table, we have two value. One value is the drone or component of swarm or drone is functioning. The other is a fault. For each of these states indicated some possibility of this state. These possibilities we interpreted as further values. Based on this table can be developed the fuzzy decision tree. It's, for example, presented for this data fuzzy decision tree. And this fuzzy decision tree by deposification and rules of transformation decision tree to decision diagram can be obtained multi-value decision diagram that without problem can be evaluated for definition indices of drone swarm reliability. In particular, if decide such initial data, compute, for example, Beerbaum importance, availability of this swarm or unavailability of the swarm. If we consider, for example, availability of this swarm is not very high, and we can propose some modification changes other type, and if we introduce drones with higher reliability, we can The second example of application of this method, it's importance analysis of input attributes in problem of prediction some values. In particular, it was considered for this problem in health care. It similar work for attribute selection method, and if say in more detail, it's combined with embedded method of attribute selection. Last example of application of this method is not typical application. It used this method for common reliability analysis, in particular for evaluation of medical team work and definition more important patient who have a mass impact for medical error. Because time is shorted, I show only result. This table was format based of decision tree for this problem, and for this team we defined state of performance level of this reliability, and we can see that fatal error is no very possibility for this team is so good. But next step in this problem was the definition proposition for improve work of this team, and if we consider this diagram, in this diagram was proposed introduce to some equipment and introduce in this team application of this team by some equipment really improve the possibility of perfect care for patient, and it's a good result of this analysis. If say generally of proposed method is method for combination of machine learning as classifier induction and multi-level logic. In particular, we use a method of multi-level logic for importance analysis in analysis in calculation indices of reliability. Last remark for my presentation is introduced for your intention workshop, which will be correlate with thematic of my presentation. This workshop will be premier in months. Participation is free without any organizing fee. This workshop online, and you can join, and maybe anybody want to participate is possible too, because deadline for abstract submission will be in 2 weeks. After this workshop will be published of Springer of selected presentation, and welcome for this workshop, and thank you for your attention for presentation of application multi-stage system in reliability analysis.
Thank you very much. Sorry for some technical problems, and now we have very short time for questions and answers. Welcome.
You can see that this problem as discrete optimization problem. For example, could you show us objective function, constraint, and so on?
I understand your question. Unfortunately, we don't use now optimization problem. Is really we near this decision this problem, because really it's need for some of application, and it's next step.
This is a project very close.
Yes.
Thank you. Any other questions? Okay, very short question. We can consider this system as multi-state systems with multi-state components.
It's not
No.
necessary. It's possible, but it's not necessary. We can define for component state a different number of states. It can be two state fault or function. It can be most. It's not important. We consider multi-state system if one of element of system, components or system have more than two states.
Yes, because it would be very interesting for UAV swarm when you can consider separate UAVs as multi-state system and multi-state system. Thank you. Thank you very much. Dear colleagues, now we have finished our morning plenary session. Now it's time for coffee break. And after that, I invite all our participants for three online track and one offline track, which will be here. And so now we have time for the coffee break. Thank you very much once more. Sorry. Very short information from Professor Sachenko about special issue in MDPI journal. Welcome, Anatoly.
Here.
Nikos.
Next section.
Giorgio. Certo dovevamo questo tanto. We have coffee break. No, it's not yet. Okay. Yes. Okay.
5 minutes.
Okay. Sorry. Okay. Schedule.
Oh, I don't see Athens. 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 Thank you, city Athens. Because I don't see.
Is it a folder? It's not here. Is it in the folder? Yes, here.
Yeah, there's a-
Okay. Copy.
Okay, I have 5 minutes. Okay, so so first of all, I would like to say thank you so much, Professor Kharchenko. Thank you so much, Professor Nikos Markis, for kind invitation to Athens and opportunity to present some information about this special issue. So this issue is open by the applied science. No, okay. No, I prefer to stand. Okay. Marina, please. Thank you. Okay. So this issue, a special issue, opened by the journal, open access journal by the MDPI, and name of issue you see there, trends and prospects in computer vision and pattern recognition technology. How to change slides? Next slide. Okay. Okay. Yeah. Thank you so much. So sorry. So again, this is journal Applied Science. You see impact factors high enough, I think. Yeah. Okay. So and here some details about this journal. You see here. Okay. Say again, impact factor, etc. Past publication. Middle time is 38 days, of fantastical fast, you know. So and other details. So this journal is cited enough, I think, with higher percentage. Okay, so and next.
For you, if you want. Oh, thank you, Slava, every time you bring. Thank you.
growing up somehow. And this is the transfer function for that. Then let us compare it with one. This is vector and this. Okay, structure. Okay, on the top and the bottom, it is the interchange and the classical. Okay, okay. Now I'm going to go slowly, you can see the difference. On the top, K3, on the left, on the right, K2. On the right is missing K3. And if you go down, you can see now that it is a complement of each other. So by interchange, the transfer function is a complement of the classical. Right? I'm going to go down again, you can see what's missing. It's missing K2, K3, K1. It's missing K3, it's not here. At the end. So therefore, by a simple interchange of the delay element, the result, the transfer function, it is take the complement, okay, of the whole response. Okay, with many implications in real applications, because you can change the whole response of the system. And again, if you compare the two realizations in state space, again, you cannot predict one from the other, are different, but actually they're complement. So further research should be done in order to compare those two structures and to arrive at results that can be, okay, to go from one to the other. This is a four order. Now it becomes more clearly the results. Again, this is the state space I derived from this. And this is the interchange delays. 0, 1, 0, 2 on the top, 0, 1, 0, 2 on the top, it goes forever. Again, this is the realization of this. The comparison, the top and the bottom, it is the classical and the interchange delays. And the comparison of the state space, again, you can see, okay, that you cannot predict from conventional to interchange with the conventional, which means only means one is the inverse of the other and nothing else. And the comparison again for 4D now becomes more clearly that it is the complement of each other, okay? It's a different filter, maybe the same characteristics in the inverse position. And we did also generalization of the results. And we extended all these in state space to the general case for this MI filter. And this is the end. So my contribution, it is a new structure of FIR filters are called MA, it's the same thing. And I gave generalizations of the state space, and also you can find generalized forms for the transfer functions. Conclusions. The structure, a state space implementation of MIA filters with flipping delay elements for such of various sets. The filter utilizes minimum delay elements n, that's very important, and also 2 to the n multipliers, 2 to the n others. In addition, the vector that represents the state space has the minimum actual dimension of n. So finally, the example shown the complement, okay, of the new structure with respect to the initial conventional filter. Thank you.
Thank you very much.
Questions?
Questions?
Equal.
Any questions?
Maybe
Maybe online.
Okay, stop presenting. So you can now see what is happening. Started sharing. You turn your microphone on to a sound check. See if they can hear you online. Yes, it's on. Share what you haven't shared yet. Yes, you're sharing. But maybe better share the presentation or you want this view. No, they don't see the.
Okay.
Yes, see.
Okay, our next presentation, it's reliability models of diverse majority redundant system with threshold adaptation. Welcome, Marina. 15 minutes,
Thank you.
not more, please.
Okay. Our research is conducted the reliability models and also methods of choosing the more reliable construction. We used classical research of duplicated control systems earlier, and for now we want to show that for complex systems which consist of hardware and software can be used more complex, more large constructions such as 4-channel structures or 5-channel structures. And in our research, we will compare different variants of these structures and show which type of control system will be more reliable. And content of this work is motivation, systematizing of 3, 4, and 5-channel of diverse majority redundancy systems, variants of these structures, generalized structural diagram, which we propose to use, and also we propose analytical reliability models and obtained dependencies for adaptive structures. Also simulation and fragments of priority rows for different structures we will show in this presentation, and method of choice the diverse structure with adaptation of microprocessor systems. Now, this picture is only to show that complex systems like Airbus, like nuclear stations, like microprocessor centralization in railways, and also the newest variants of rockets and space crafts, they use complex control systems, microprocessor control systems, and priority of these systems are in safety and in reliability, and not always in cost. So for these systems can be used complex realization of structures. Goal of our research is to research reliability of unattended diverse majoritarian redundant systems, and we will explain reliability of non-adaptive structures and adaptive majoritarian redundancy structures. And also we will propose the method of reliability ensuring and developing personal internet service provider.
We need to
Yes.
reload the tab that has got the connect. Ah, you're still visible.
Yes, because I use my little connect
Yes.
here.
Disable the connection.
Yes, so. We can see here that there are some diversity, majority redundancy systems. We will use the set of diverse structures as S abbreviation and N channels, M versions, versions of software, channels of hardware. And we can see also that we have a number of channels in diversity, majority, redundancy systems. For different structures, for example, 3 channels of hardware, 4 channels of hardware, 5 channels of hardware, we propose different structures. For example, we have 3 channels of hardware and version distribution like 3 hardware channels, and also the number of software versions. And for first variant is the only one. Also, a type of structure, we have 3 channels, 2 and 1. And we have here 2 hardware channels and 2 software versions. And also, you can see that for different variants of structures, we explain in this table that there are different variants of structure, hardware and software number of versions in our control system. For with assumptions like subsystem failure occurs when one of redundant outputs, the number of errors is equal to or does not exceed the failure threshold. And also the research of the main indicators of reliability, probability of failure-free operation consists of following steps. First, systematization of the set of diverse majority redundancy systems structures, partitional of whole set of states of these structures into 2 subsets, where we have complete set of all operable states of this structure and 2 subsets, service-able state and state associated with a failure. And also that hardware embedded control is used in microprocessor control system. And this is majority element with comparison. About different structures, we also use not only non-adaptive, but also we research adaptive structures, which can be, like, for example, the system operates as a conventional majoritarian architecture and switches after the second failure to one working channel. And example of this structure is 3-3-1. And the system switches after the first failure to operate with the 1 or 2 remaining working channels. And if we have only 1 as working channel, the other will be loaded in reserve. And many variants of the structure can be shown as multiple, where we have set of variants of realization of non-adaptive and adaptive majority functions and different variants of structure. Also, you can see here variants of structures by number of failed channels. And you can see that if we don't have failures, it will be 0 failed channels. And also we show here that for 5 different variants, we can have some adaptive structures by number of working channels in remaining of reconfiguration. Now, for example, for 5 channels, different variants proposed in first part of this table, and you can see that in some variants we will have all 5 channels in working state, and in some variants we can see that will be failure of all structure. And here we can see also the comparison for non-adaptive and adaptive structures. With non-adaptive, we researched schema with majority elements, 2 out of 3, 2 out of 4, 3 out of 5, and 2 out of 5. And you can see here that we propose also, it is a new scheme for 5 channels with also some versions of software. You can see 5 versions, A, B, C, D, E software versions, and also hardware channels 5 here. And you can see that different variants of majority redundancy, 2 out of 3, 2 out of 4, 3 out of 5, 2 out of 5. Also, and multiplexer, like switching block here. Also, there is a control block for channels. And also, we have here control system. And we have some assumptions. We use the main indicators like probability of failure-free operation for hardware, for software, and also we used failure rates of different components. And for this structure, we proposed analytical reliability models for non-adaptive 3-channel, 3-version DMRS, for non-adaptive 4-channel, 4-version DMRS, non-adaptive 5-channel pentaversion, and non-adaptive 5-channel pentaversion. And dependencies we obtain with using of logical probabilistic method for different structures of control system. And after this, we proposed also, this is like some values because we had many of them with, for different structures, which probabilities are minimum and which failure rates also like minimum. And after this, we propose graphical dependencies for different structures with using different values of initial data. And we can see in these graphical dependencies that not always using of 5 channels with 5 redundancy of like redundancy of software will be useful because the values of probability indicators will be not so large in difference with others. And according to obtained reliability models, according to dependencies, which we also simulated and analyzed, we proposed priority rows, priority series for different structures. And you can see here, not all, but for some discrete states and for some intervals of time and for some intervals of probabilities, for hardware and for software, for different failure rates, we proposed priority rows for different structures: 5-channel, 4-channel, and 3-channel. And here you can see that we have more large values of priority if we have more large value of probability failure-free operation. We propose the method. Method will include some steps of our research work. So, firstly, systematic analysis of existing diverse majority reserved structures. We looked from the point of view reliability on it. Also, the main reliability indicator was used to evaluate the reliability. It was probability of failure-free operation. After this, we obtained analytical models and calculated the indicator of reliability. After this, perform simulation and analyze our analytical dependencies. We analyze also results of it and build priority series. And after this, we can show to producers, to manufacturers, which variants of different structures will be useful, will be more reliable for their systems. Of course, if we have more information about statistical data from different systems, it could be also used for with using this statistical data and also for the concrete manufacturer. So, as conclusions, we can say that all our goals were reached in this research and method, priority series, analytical models. All of this were proposed.
Thank you very much. Any questions, please?
Maybe there are some questions.
Mm-hmm. Dear colleagues online, maybe you can ask if you any questions.
Maybe Vyacheslav Sergeyevich also ask me.
Maybe not understandable as co-authors.
Yes, because you might
But we talk about threshold adaptation. Is a traditional, yes, adaptation
Yes.
connected with changing of threshold depending on number of failures. Yes.
Yes.
What about possibility of version adaptation? When we talk about changing of number of version, software version, in this case, we could use version adaptation as well, or structure version adaptation
Here, yes, the new improvement methods. It is because we only not only hardware versions use here, but also we research software adaptation and software versions. So and different structures. So this work is very large because we used many types of variants, and we had to understand which is more reliable. And with using not only hardware but also software, and in two variants, with non-adaptation and with adaptation. So this
thank you, and I think it may be a very interesting point to take into account more in detail complexity of means for adaptation, because we can develop more adaptive structure, but for that we need more software and hardware support for reconfiguration. Hence, it may be a very interesting point to to make more accurate assessment of this structure.
Yes, because we now have assumptions that they are ideal. So yes, we can do it.
Thank you very much for your
Thank you.
presentation. Yes, and it's my pleasure to invite for next presentation, Lyudmila Kirichenko. Welcome.
See, and go back.
I would like to present for you some results of our study of heterogeneous diffusion. Very short about first, what is anomalous diffusion, what is challenge anti-anomalous diffusion challenge, and which problem and the objectives there were in this challenge, and our methods for to identify of heterogeneous of trajectory of diffusion, and some results and conclusion. First, when we say about anomalous diffusion, Brownian motion or diffusion process of some movement of particles is well-known and fundamental concept of in biology. And particle case of Brownian motion, particles of all processes of diffusion is anomalous diffusion. In this case, in case of anomalous diffusion, we have scaling relationship between mean square displacement of particle and time. In this case, we have time to the power of alpha, and alpha is exponent of anomalous diffusion. When we say about anomalous diffusion, in this case, square displacement, MSD, is K multiplied to T to the power of alpha. K is the diffusion coefficient and alpha is the diffusion exponent. And when we say about homogeneous time series, homogeneous trajectories, for this case, we have the same K or alpha. If we say about heterogeneous trajectories, we say about different K. For example, two-type diffusion, we have two values for K and alpha. And our methods, which we are proposed, are based on the fact that our square displaced follow the exponential distribution. Why? On this figure, you can see it's our trajectories on the plane, two-dimensional. In this case, we have component X and Y component of Brownian motion. Every component has normal distribution, and we have sum of square normal components. And in this case, we have chi-square distribution with a degree of 2. And it is chi-square distribution with degree of 2 is exponent distribution with some parameter lambda. And this parameter lambda depends on characteristic of anomalous diffusion, depends of K and alpha. And our task, we have to, if we have homogeneous trajectories, we have the same lambda. And if we have the heterogeneous, okay, we have the different lambda, and we propose 3 methods how can identify the heterogeneity of trajectories. First, we know that we have exponential distribution. In this case, we can use the goodness of fit test statistical hypothesis and check the exponent distribution, different lambda or the same lambda. For this case, we use this test. Second, typical, we can use sliding windows methods and calculate mean for every windows and compare this means of between. If we have different values of lambda, we have different mean of windows. In our case, we proposed instead mean use median. For exponent distribution, we have this relationship between median and mean. And median is more robust characteristic than mean. And in this case, if we use median and calculate median on every window, we have a lot of values of medians. And in this case, due to central limit theorem, the distribution of medians is normal. And in this case, we can use Gaussian mixed model. It's a tool of machine learning. It's a clustering tool, and we use this tool to identify that we have different types of diffusion. Okay, we proposed 3 methods, and it was competition, and organized known the correct answer, and use a matrix of root, mean, square errors, and Jacquard matrix. And for our three methods, we have this matrix, the minimum of square errors for histogram-based method, the maximum of Jacquard coefficient 2 for histogram-based method. And I want to underline that in competition between 18 teams for this matrix, we have fourth and fifth places. And our result were very close to results of winners for this matrix. And that's all I have to say. Yeah, I finished. And we proposed new methods how we can identify the heterogeneous tracks of diffusion. And I hope all result of challenge will be published, and I hope our result help for another researchers for in this case.
Thank you very much. These questions? Yes, we have questions. Marina, welcome.
In Python, in Google Colab, all competition was in Google Colab. You can see its site of competition, all programs in Google Colab, datasets in I do for Python too. We can use Python for read datasets.
Okay. Professor Sachenko, well.
Thank you so much for your presentation. It's nice. So my question is, from I guess some your presentation, how to describe your approach in some domain? I mean, like, management or something like that.
Example of application.
Application?
Yes.
For example, application, it's models of real biology processing. Biology, in biology. Mm-hmm. Real processing.
Okay. Thank you. Other questions? It's mine, no. Thank you very much.
Thank you for you. Thank you for invitation.
And next, our presenter, Sophia Drost. The presentation, Sophia Drost and Natalia Kukushun. Strategic wind farm site selection in Ukraine using this and multi-criteria decision-making approach. Welcome, Sophia. Nico, please.
Okay, you open.
Yes, I need to open my presentation on the flashcard. Wind and this.
Yeah, this one.
Huh?
Okay.
So, hello everyone. My name is Sofia Drost. I am master student at the Department of Mathematical Modeling and Data Analysis at the National Technical University of Ukraine, KPI, and researched at Space Research Institute of Ukraine. Today, I have the honor to share with you our research, namely strategic wind farm site selection in Ukraine using GIS and multi-criteria decision-making approach. So let's start. As many are aware, Ukraine is currently at war, and the main hardest hit sector is energy. For example, by 2022, Ukraine lost a half of its energy capacity. And by 2024, the missile strikes on the largest hydro and thermal station resulted in the loss of over 70% of Ukrainian energy capacity. Because of this, now country is facing Can you hear me now? Oh, and because of energy shortages, it is really difficult to supply even crucial infrastructure with energy. However, there is a solution: decentralization. There is easy to attack land, but it's really difficult to destroy 1,000 small solar or wind power plants. And to achieve this goal, our government has a renewable plan, namely a renewable energy action plan by 2030. And they want to achieve 24 gigawatts of wind energy capacity in Ukraine and construct more than 6.1 gigawatts of offshore wind power. To achieve the best productivity of wind power plants, it is necessary to identify the best location where should these power plants be built. And the efficiency of wind power plants are affected on several factors like climate, topography, infrastructure, safety, for example, and so on. And it's really challenging to assess these criteria directly. And because of this, we propose to use remote sensing, satellite data, and GIS. When we construct multi-criteria decision-making approach, we want to identify the best locations for wind power plants to achieve better productivity of these power plants and help our country restore destroyed energy sector. And to achieve this goal, we use different criteria data. For example, we use climate data like wind power density from Global Wind Atlas data from ERA5 plant, as you can see on this slide, about temperature and duration of wind with unsuitable speed when these wind power plants cannot work. And also we use environmental data like land cover, slope from NASA shuttle redetermination, and also we use socio-economic factors like distance to power lines, distance to main roads, and safety map. So here you can see shortly our methodologies that we apply to identify the best areas for wind power plants. First of all, we select the set of criteria, as you can see in a previous slide, and then we reclassify these criteria according to the table shown at right slide, and we do it to make our data comparable. So score 0 is a really unsuitable value of criteria for wind power production, and score 5 is the best value of criteria to product wind energy. Here you can see the examples of reclassified criteria maps that we have obtained. Different scholars define different suitability. For example, red is the really unsuitable areas, and green is very suitable areas to product wind energy. Here you can see reclassify safety maps. We built these maps using ACLAD data. This is data about armed conflict location event data worldwide. And these maps illustrate count of attacks averaged by year from beginning of the war to 2040. So, and here you can see pairwise comparison matrix that we obtained to identify by coefficient for each our criteria. We want to know how if one criteria is related to other criteria according to importance to product wind energy. And we conducted experts surveys, and each expert said how one criteria is more important using Satie scale against to other criteria. And to identify consistency of this matrix, we calculated consistency ratio. The R value is 0.07. And this is less than maximal available value according to Satie, namely 0.1. And using this matrix, we calculated the coefficient for each criteria that we will use to build a less suitability index using weighted linear combination. As you can see from this formula, we use reclassified criteria and weight coefficient, and then we summarize each weighted criteria. Also, we apply land restriction. This is some land classes that is really unsuitable for construction of wind power plants. For example, water and so on. So, and now let's review our results. On this slide, you can see land suitability map of Ukraine for wind energy development. This map consists from unsuitable land to very high suitable land. As you can see from this slide, the worst areas is located in mountainous areas like the Carpathian region, also south part of Crimea, and some regions of South Ukraine. And the best areas to produce wind energy is located on the Azov and Black Sea coast, and also at the West Ukraine, for example, Lviv region, Ternopil region, and so on. And also, very promising areas is located in Luhansk region. When we look at the diagram at the right, you can see that the most part of Ukraine has moderate suitability to construct wind energy and develop this energy, this type of energy. And now let's go to the conclusion. In this study, we created a land suitability map for development of the wind energy and construction of the wind farms in Ukraine, using multi-criteria decision-making approach and satellite data and GIS. We identify as the most important criteria to assessing the land suitability for wind energy construction is the duration of unsuitable wind speed, wind power density, and also according to the numbers, the whole of Ukraine has moderate suitability, and near 40% is really unsuitable due to the land restriction and also in infrastructure restriction, but other area is highly and very high suitable to product wind energy. This means that Ukraine has have high potential to develop wind energy, and can recover energy supply and suitability of energy sector of Ukraine using green technology. So, research was supported by the UCAN project, also founded by Horizon Europe program, and also National Research Foundation of Ukraine and Ministry of Education and Science of Ukraine. So, thank you for your attention.
I think due to your presentation and your research, we will have a very powerful wind grid in Ukraine. Thank you. Any time for questions? Any questions for me?
It looks like you try to make overview of all the countries, right? My question is, how much can you charge to the satellite results? What is about techniques?
So, resolution, for example, of ERA 5 land data is 9 meter. This is ERA 5 data provide modeling data, but we can trust this data because we have validated, for example, wind power density with other sources, and also we use data from OpenStreetMaps. I think we can trust this data because when we look, for example, on Google Maps, we can see that the infrastructure from OpenStreetMaps and from Google Maps are same, for example. As for Aqua data, I think also we can trust this data because it is a worldwide project, and many people, many researchers use the data, and we have many publications about validation. So unfortunately, we have no data about wind farms in Ukraine to validate our results. But maybe when we found this data, we can validate and provide your numbers about suitability of our lands, our maps. But now we can just think about the validation from papers about data we use in this research.
However, I didn't get what criteria did you use to define the ways, the corresponding ways, for example, bypass numbers, for example,
this decision was made by experts. So when experts think that one criteria is more important than other, they just write a score using sanity scale, and this is experts. And experts know how important it is. It is just mining. This is pairwise comparison method. And to identify is this matrix consistent or no, we calculate this consistency ratio. And when matrix is consistent, we can use these coefficients for a further analysis.
Okay. Online questions? No, we don't see. Yes. Okay, thank you very much, Sophia, for your this presentation. Okay, and now the last presentation of this session. Mikhail Kepolakis, Nikolaos Karadimas, welcome. Presentation of site selection of object detection training using landscape extraction, fragmentation. Welcome. Yeah. Check the presentation. Yeah. Welcome. So, I'm sharing.
So, greetings everyone. My name is Michalis Kefalakis. My background is in computer science, biomedical informatics, and I recently obtained my master's in security, cryptography, and information systems, specializing in geospatial information systems. My research interests lie in synthetic data generation, computer vision for object detection and remote sensing applications. Before we get started, I would like to thank the authors for their amazing contributions, and I hope you will enjoy our presentation as well as you enjoyed theirs. I would also like to thank the professors and the IEEE members for their hospitality. So let's get started. This article, Site Selection for Object Detection Training using Landscape Structure Fragmentation Indices, was co-authored with Professor Nikolaos Karadimas of the Department of Military Science of the Hellenic Army Academy. So let's begin our presentation. Remote sensing is a rapidly evolving academic field with numerous studies proposing solutions for training AI models. But what do remote sensing images all have in common? The answer is landscape. Paradoxically, despite the significance of landscape structure in remote sensing, there is a lack of studies that directly evaluates how to select training data based on the landscape structure statistics of the areas being observed. The purpose for developing this method is to select the data with the most landscape variability in an effort to create better performance observed. What we hope to achieve is to create models that strike a balance between generalized and context-specific performance. By capturing the landscape structures that are significantly different, we can avoid redundant data that do not have anything more to offer to the model. Redundant data can potentially lead to overfitting or over-specialization in particular area distribution. By using data that are variant enough in their landscape structure, we can make a more generalized model tailor-made for a specific area distribution. So, in this particular example, we can see that the first three images are very similar. So, adding them all to the model may be redundant information, but we cannot exclude them all as they are part of the territory the drone is sent to observe. So, although we cannot easily decide with our vision which one has the most variability, we can make a method to select it. In the second images, due to the complex positioning of the buildings, it's even more difficult to assess which photo may represent the highest variability. imagine that in this scenario, we only added 3 images. In a real-world context, there will be exponentially more. So we broke down our methodology into 3 distinct phases so that it is more easy to follow. We have the data collection part, the data for image data. The images were downloaded from OpenEarthMap and represent the land of Zanzibar, along with their segmented images, which are needed for the calculation of landscape structure matrices. OpenEarthMap, for those interested in GIS, is a remote sensing semantic augmentation benchmark dataset. It consists of data covering countries from 6 continents, and is at a spatial distribution of 0.5 and 0.25 meters. So after we obtained the images, we had to augment the clear images to place our object of interest. To achieve this, we used drone masks and the image overlay. We used tilt and rotation to avoid overfitting the model in particular formations. So in the end, we had to extract the landscape structure and the fragmentation indices for each area depicted in the image. To extract the matrices, we used the R package for neutral landscape generator called RFLSGen. We use the RFLSGen extract structure from raster function, which takes basically as a reference segmented image and returns a JSON object of the landscape matrices and fragmentation indices. These are the statistics and the matrices the RFLSGen is able to calculate. Generally speaking, some of the metrics of the landscape are regarding the patches of each class, and some explain their border division and the separations, if you may. So for the data processing, we first had to clean the data sets. Some variables didn't provide information, they were removed. We also removed the raster name variable, but not before we mapped each row into its name so that we can later put the selected rasters to it. We also standardized the data to have them in an applicable format for principal component analysis. So for the visualization enthusiasts, including myself, we calculated the 2 principal components and we plotted our data. From the initial plot, we can see that by calculating points with most variance, points in dense clusters might be not included. So to fix this, we tried the second approach by using the density in the plot. Doing so, because the density of the plot is based on all the data of the plot, some spatial distribution of the plot will remain unseen, meaning some small clusters and even larger ones may be not taken into considerations. To select the images that vary the most but by also having each spatial area covered on the plot, we divided it low. So as I was saying, we also selected for the first model validation dataset, and for this one we created two variations of the image. So in the end, for the first dataset, we had approximately 700 images, and the training to validation ratio was it was 4:1. Now for the second model, training data were selected from the areas that were chosen as high variability from the PCA plot. And for validation data, we selected areas that were excluded due to low variability. This is important. The area that was used in the second model had low variability in the validation data set. The recommendation of the data will remain the same. For both models, data were selected from each grade so that validation and training are representative of the task the models are made to do. Architecture, we use the YOLO version 8 model for object detection. It's a one-stage object detection model. It's based on CNN architecture. Interestingly, we observed that model 2 exhibits lower accuracy. What stands out is that model 1, despite being trained without specifically considering data variability, still achieved a good performance. This may be due to its validation data being sufficiently scattered to the plot, representing a broad range of points, likely including many accidentally, maybe with high variability. Model 2, on the other hand, was trained with data showing high variability, but its validation data reflected low variability. This suggests that the model trained on the low variability data can still perform well when its validation data reflects variability, while the opposite is true. While we are not advocating for this as a definitive approach, it might serve as a useful risk mitigation strategy if needed. Insights and further control experiments are very essential to refine our validation data selection. For instance, our next step is to train model 2 using both training and validation data that both capture variability, and we should ensure some deliberate validation data selection for model 1 to test our hypothesis further. So for our future work, of course, as I referenced before, we need to fine-tune our math for the selection of the most variant points, but simultaneously maintaining the spatial coverage on the plot. Inclusion of more in-depth segmentation classes to explain the landscape structures such as vegetation type, building type, ground type must be considered to have a more detailed data set and have a less biased selection of points. Experiments must be conducted for many more areas. We would like to use this method to detect which object detection models might be outdated and generating synthetic via digital twin of the area. The creation of new artificial areas by introducing noise to the landscape indices for targeted area surveillance, or by generating new synthetic points based on the PCA plot. So we have reached the end of our presentation. We'd like to thank you everyone for your attention, and I will be happy to answer some potential questions. Thank you.
Thank you very much. Question, please. I have a question concerning collection of data sets.
Yes, please.
There is a problem navigation of this data using RTK and other technology.
Yes.
RTK or GPS, for example, to synchronize this information. It's the first question. And second one, what do you think? Can we use this data set? Can we get using UAVs to share, to multiply new data set?
Yeah.
Considering problem with weather, climate, and so on.
Yes. So for the first question, what I would like to mention is that yes, we have a problem with real-time data as the areas being observed are dynamically changing due to time and Earth processes. So what some research might suggest is that we can calculate from sentinel products or products with lower GSD and try to reach conclusion for what happens in a higher GSD. Unless you have access and the financial capability to obtain data with more high GSD, which are in near real time updating. So for the second question, which I would like to have a complete talk about it, but let's sum it up due to time constraints. What we can do in this particular scenario is to create a digital twin of the area using either the PCA plots or even the same segmentation images. And then simulations and object placement with various formations that might be included in real-world scenarios. If we include real-world formations, there might be a slight process, because imagine that you might have a vehicle placing in parking lots, but in a real-world context, those vehicles may be unwanted and parked on the side of the road. So you have to also consider edge cases if you're about to use real-world statistics that exclude outliers. Thank you very much.
Any other questions? No. Thank you very much.
Thank you very much
for your presentation. We have finished our session, and now time for.
Yes, we have time for lunch, so we can go upstairs where they are.
Yes. Okay. Next session we will start 2:30. Okay. Mm-hmm. Thank you.
So you can go upstairs by yeah, yes.
Hello, everybody. Our next session is starting now. Sorry for the small delay of our lunch time that we had in Athens offline. So we're starting with the first presentation of Ioannis Iordanis and Christos Koukouvinos, and the title of the work is Cluster Analysis Machine Learning Using Progressive Latin Hypercube Sampling. Please, Mr. Iordanis.
Συμβουλεύστε εδώ. Ναι. Πώς αλλάζει διαφάνειες. Νίκο, γύρκεται και δεν αλλάζει διαφάνειες. Εγώ αυτή τη στιγμή έχω μπροστά μου το παράθυρο του WebEx, όχι το...
Α, ναι, γι' αυτό.
Ναι, αλλά πήγαμε γύρω στο τέτοιο.
Πάμε στο presenter.
Hello everyone, my name is Ioannis Iordanis and I'm going to present a study with respect to cluster analysis in machine learning using progressive lighting hypercube sampling. This study was prepared by Christos Koukouvinos and me. Here is the table of contents. Motivation. In a model society, a large amount of data is generated and needs to be processed in order for valuable information to be extracted. This process requires modern mining tools, and these are what we are looking for today in machine learning models. These models are effective but prone to uncertainties and variations in data, which can lead to reduced accuracy and reliability. To address this issue, various techniques have been proposed to improve model performance, and among them is the use of sampling techniques that create high-quality data files to train the model. In this context, the Latin hypercube sampling, specifically progressive hypercube sampling, or PLHS, is investigated. So start. I don't have a pointer here. No, never mind. Laser.
Μόνο το βελάκι, δεν το κλείσει, δεν αλλάζει.
Όχι, το. The Latin hypercube sampling is a method aiming to reduce the number of sample points required to achieve an accurate result. Conditional Latin hypercube sampling, CLHS, was first introduced by Nancy and Mark Barakney in 2006. In a more recent study by Yang et al., CLHS was implemented with machine learning, ML algorithms, to investigate the quantitative impact of sample randomness on soil. During a recent study, LHS in different supervised machine learning models is a very effective approach. And in 2023, we extended this approach to PLA test in supervised ML with very positive results. The objective. In PLHS, the properties of Latin hypercube are preserved, and as a result, the sample produced is as representative as possible of the database. Moreover, the sample is constructed in an economical way. However, this feasibility of using PLHS should be accompanied by evidence that sample quality for use in market application is indeed effective. So an appropriate way to evaluate PLHS is to use it with ML models. So in this study, we will extend the evaluation of PLHS by applying the extracted samples to unsupervised learning, specifically in clustering, by examining the accuracy of the results compared to the corresponding samples generated by RS. The problem with LHS is that a strictly correct Latin hypercube with good space filling qualities isn't always possible to obtain, since the desired combination of variables doesn't always exist in the population, and the columns in datasets may be highly correlated, especially when the datasets include many features. The solution is the implementation of practical criterion of LHS, requiring the generated Latin hypercube samples to mirror the real conditions of the dataset. This is achieved using objective functions O1, O2, and O3, which are included in the CLH software by Minansi and McBratney. Using the same objective functions, we developed CPLHS algorithm from CLHS. And like CLHS produces LHD matrices, CPLHS produces PLHD. First, let's explain what PLHS is. Based on LHS by Sekoslami and Razavi, defined PLHS, which practically says that first, a sample S1 in a form of Latin hypercube L1 is generated. And then L1 is enriched with new sample points S2 and generates a new sample L2, which is also in the form of a Latin hypercube. In the same way, sample L3 is progressively constructed, and the process continues until the desired number of T samples is produced. This way, the sample is constructed in an economical way, since a large part of the sample for each subsequent sampling step has already been obtained from the previous step. PLHS can be used when we don't know the minimum sufficient size in advance. And of course, it is used for economic reasons, since the old sample can be reused in the new one. In such an increase of the sample size, we have the advantage of having uniform densification of the sample, and that the unsampled areas are reduced. The clustering models we used are K-means, GMM, HAC, DBScan, and HDBScan. K-means, GMM, and HAC require the number of clusters as an input. And on the other hand, DBScan and HDBScan are based on the density of the sample points, and they determine the number of clusters by themselves. Hyperparametric tuning was done with grid search, and the metrics we use to evaluate the clustering models are V-measure and adjusting neutral info. The three datasets we used were selected so that to have at least three classes, the Latin hypercube approximation index, which I will explain later what it is, to be over 80%, and by applying the default values of the hyperparameters to the model, to yield appropriate values so that the comparison of sampling to be in a satisfactory range of values. Also, each dataset was checked so that each observation is unique. In each observation, the value of the hyperparameter of the attributes must be fully filled in. There is no strong correlation between the characteristics and there are no outliers. And in this table are the selected dataset after pre-processing and the objective of the clustering. The IRIS dataset, it has 150 records, and the goal is to identify the type of iris plant among 3 types based on the length of and width of sepals and petals. The Wi-Fi dataset has 2,000 records of signal strength recorded by a cell phone. And these signals are from 7 different sources. And the goal here is to find in which room the cell phone is. And the dry beans dataset, it has 8,026 records of bean data. And after pre-processing, and we have 10 features, 6 of which are the dimension of the beans, and 4 refer to the shape of the bean. And the aim here is to identify the type of bean. Now about the sampling. Since the clustering process doesn't need the separation of datasets into train and test sets, like we have in supervised machine learning, sampling was done only with fixed rates and directly on the dataset. Specifically for each dataset and for each sampling method, we produced 4 samples with sizes approximately 35, 50, 65, and 80% of the population. Each sample was applied to 5 clustering algorithms, and to reduce the randomness, this procedure was repeated 10 times. For each dataset and for both sampling methods, we obtained 80 samples, so we have a total of 240 samples for all 3 datasets. Now, about the approximation index. Related to the objective functions is the approximation index to a Latin hypercube, which is given by this formula. Basically, AP shows how correct the resulting LHD is. If we have AP equal 1, then the sample is a perfect LHD. And here we see a table that presents the average value of the approximation indices to Latin hypercube. Since those indices have high value, where the objective functions are applied, we expect the samples to also have very good space filling, which will be depicted in the following figures. Here we have the real coordinates and the LHD coordinates of the 35% sample of dry beans dataset. The blue points correspond to the population and the red ones to the 35% sample of the population. Within the range of features values, it is evident on both figures the very good space filling by the 35% sample. In this figure, we have a sample of 53 points by the IRIS dataset for RS and PLHS, and it is observed that the RS sample points are more concentrated to the same horizontal and vertical grid lines compared to PLHS sample points. Here I have the coverages for each. And in the next three tables, we show in detail for each sampling method the average values of the metrics of the 10 samples. In IRIS dataset, the best metrics with values from 0.89 to 0.92 are produced by the GMM model, while in the Wi-Fi dataset, the best metrics are produced by HAC and GMM models with metrics greater than 0.88 and 0.93. The metrics in the dry beans dataset are generally low, with the GMM model achieving the higher metrics. This lower performance in the dry bean is probably because of its features. In IRIS and Wi-Fi, the features are a measurement of physical and experimental data that provide some spatial similarity information consistent with clustering. But in the dried beans, there is those four features that are engineered to try to mimic the shape of the beans. So the performance may be reduced because of that. In all three datasets, dbScan and HDBScan models have the lower metrics. This is because the performance is calculated by comparing the number of classes in each set with the number of clusters estimated by those models. The other three models, we have the number of clusters and input, as I said. But dbScan and HDBScan in many samples estimated the clusters wrong. Like we had 2 clusters in IRIS instead of 3, or 5 clusters in Wi-Fi. And in dry beans, it was even worse because in many samples, the estimated clusters were even multiples of the actual clusters. This table shows the total results per dataset and per sample size for all clustering models. And we can see that the PLHS improves the results of clustering algorithms. In 49 out of 60 cases, PLHS prevails over RS, especially in HAC, where PLHS wins over RS completely. However, it should be noted in the dbScan model, the results are in both sampling methods practically do not have any difference. Finally, here we have a table with a comparison of different sample sizes and sampling methods. In supervised ML, this kind of comparison showed that smaller PLHS samples can provide more accurate results than largest RS samples. But in clustering, this comparison may have no real added value, since the process will eventually be done for the whole sample. Nevertheless, the small sample size could possibly offer resource savings in studies with very large databases, where we try to find the right number of clusters. So in this table, we can clearly see that in most cases, small PLH samples produced better results than bigger samples created by RS. Concluding, all PLH samples had better space filling compared to RS. In the examined examples, RS space filling covers about 60% of the space filled by PLH samples. This fact makes obvious that PLH samples represent better the properties of the whole population compared to RS. Among all clustering models, better results were achieved by GMM. PLH sampling improves further the results of clustering algorithms, even though the metrics of PLHS and NRS in some cases had some minor differences. It was found that in about 80% of the cases, PLHS produces more accurate results than RS. Specifically in models where the number of clusters is required as an input, that means k-means, HAC, and GMM, PLHS gives more accurate redistribution than RS, especially in HAC where all results were in favor of PLHS. In the other two models where the number of clusters is estimated, the improvement of PLHS is limited. Basically, it could be considered satisfactory in HDB scan, but not in DB scan where the results were more or less balanced. These are the references. Thank you very much for your attention. Any questions, please? Do we have any questions from the web? Αν σηκώσω χέρι θα το δω. Okay, we have no questions from sessions. So I have a small question. This is the sum that we are doing in it's not for big data. It's a research that could to see if there is a point to applying to big data. It could possibly be applied to big data, since in big data the main problem is the volume of the data themselves. So by applying a sampling method that provides good results, we can take a small part of those big data. Have you made any experience about any results on that? We haven't done any yet, because this is in an experimental phase where we have to control the results to see whether it's useful or not. Thank you very much. Any more questions? Okay, thank you very much. Okay, our next talk is by Maria Buchner. Famous in Maria
Και να κάνουμε present το δικό σου. Σε τι είναι το διάδειγμα. Κάτσε να κλείσουμε το υπόλοιπο, γιατί ο άλλος που έχει σε PowerPoint θα μπερδέψει. Εδώ πέρα στο Μιτζέλο να γίνει share από αυτό.
Our presentation is about constructing orthogonal latent hypercube designs. Latent hypercube designs are a special family of combinatorial designs. They were introduced by Mackay, Beckman, and Conover, and they were introduced by Mackay, Beckman, and Conover, and their properties make them suitable for planning experiments, data selection, and machine learning. The definition of Latin hypercube design is an n by m array, each column of which is a permutation of the elements of the set 1, 2 through n. We very often use an equivalent definition for a Latin hypercube design, and we say it's in its centered form if their elements are centered around 0. So the design on the left is the design on the right is the center form of the design on the left, and the elements are centered around 0. Latin hypercube design will set to be symmetric if for any row d minus d is also one of the rows in the design. And one more thing, since they're used in statistical research, it is often very important to examine the correlation between the columns of the matrix. So we use this, use the correlation matrix R of the Latin hypercube design. We define it as this. And we say that the Latin hypercube design is orthogonal if and only if its correlation matrix is the identity matrix. This is an example of a symmetric and orthogonal Latin hypercube. Orthogonal Latin hypercube designs are very useful in application, and this is why a lot of research is focused on their construction. Here we give some examples. And now we will present an algorithm for constructing symmetric and orthogonal Latin hypercube designs of order 2 to the t by 2 to the t minus 1. The core element of the algorithm is a vector division procedure which divides a given vector into parts of a specific length, reverses the order of the elements of each part, and negates the second half of its reversed part. So for example, for a vector here with 8 elements, if we want to divide them into parts of length 4, we reverse the order of the elements of each part, and then we multiply by -1 the second half of each part. So in order to create symmetric orthogonal Latin hypercube designs, we will begin with the first column, this one, C1. We order the elements like this, 1, 3, 2 to the t minus 3, 2 to the t minus 1, and then we have the same elements multiplied by -1. And we apply the VD procedure so that C1 is divided into parts of length 2, then into parts of length 4 and 8, up to 2 to the t minus 1. Each part is reversed and negated as previously described. And we continue by applying again the vector division procedure to the columns that we have created in the first step. And we continue like this. Some criterion that we have in order to create new columns. If a column Ci was made by dividing a previous column into parts of length 2 to the s, then we will divide Ci into parts of length 2 to the s plus 1 up to 2 to the t minus 1. And if a column was made by dividing a previous column into parts of length 2 to the t minus 1, then it will not be used for constructing new columns. The algorithm will end when there are no new columns that can be created. Now, the way in which the elements of each column that we make are partitioned and rearranged guarantees that all the columns will be orthogonal to each other, and the number of columns that will be created is 2 to the t minus 1. So we'll describe the vector division algorithm briefly. We will use two functions. Function VD that applies the vector division procedure to a given vector, and function LHD that will create the symmetric orthogonal design by appropriately applying function VD to the columns of the design. At first we have this function. It reads a vector C and the value K and applies the VD procedure on C by dividing it into parts of length 2 to the K, and actually that's what we described before. This is the code. And then we have the function LHD that reads the value T and returns a symmetric orthogonal Latin hypercube design of order 2 to the T minus, 2 to the T by 2 to the T minus 1.
This is the code for the function. As we said before, we have to keep track while we're creating columns on how the columns themselves were created. So we have a vector D for every who has 2 to the t minus 1 entries, and for every column Ci, the entry Di will give us the information we need in order to know how we will create new columns from Ci. This is the code here. Some words on the complexity of the algorithm. Due to the lack of floating point computation and the requirement of only permutation and negations of columns, function LHD is effective and introduces no rounding error and is executed rapidly. We have some execution times here for various teeth. Here we have an example of how to make a 16 by 8 Latin hypertext design. We will begin with this column. Here we order the elements in ascending order. And then from this column, we create 3 more columns, which is going to be column 2 here, column 3 and column 4. Then from column 2, we will create column 5 and column 6. From column 3, we'll create column 7. And finally, this is going to be the resulting design. We can verify that it is orthogonal by evaluating the correlation matrix. And this is our method. Now we made some comparison with a method introduced by Sun, Liu, and Lin in 2009. Their approach constructs its Latin hypertext design progressively from the previous designs. And by making this comparison, we see that the 16 by 8 design made by our algorithm is equivalent to the design made by Sun et al. We can rearrange the columns of the two designs and multiply some columns by -1, which means that they're isomorphic. And we have also proved that the designs of orders 32 by 16 and 16 by 32 and 128 by 64 constructed by the VD algorithm are isomorphic to the corresponding designs provided by the Sun et al. Method. And some conclusions here. We developed an algorithm constructing symmetric orthogonal Latin hypertext designs of order 2 to the t by 2 to the t minus 1. The algorithm is effective and introduces no rounding error. The obtained Latin hypertext designs have good properties and can be used in many applications. The resulting designs are isomorphic to the ones provided by Sun et al. A general proof for the equivalence between the two methods is under study. And also for future work, combination of this algorithm with other construction methods in order to produce designs of other orders and with different properties is also under study. And here are some references.
And to go backwards. Any more questions, please? Yes, Professor.
Yes, my question is how fast is the algorithm as the order of the design completes? I can see some results in the paper, but I mean in general, you can talk about the complexity. And the second question is understand that the Sun exam, so your results are isomorphic to the Sun and all exam. And to prove the equivalence, it's understanding. Can you give some progress on this problem?
Some little progress, yes. About the times, the execution times, here T here is refers to the T we see here in function. So that means that we create a design of order 2 to the T by 2 to the T minus 1. So we see, for example, in the last row,
where t is 12, that means that we can construct a 2 to the 12 by 2 to the 11 design in 1.2 seconds, which is quite fast. I couldn't try with my computer.
But University of Athens, you have supercomputer.
I will use them.
Yes.
Yes.
Any more questions, please? From our session website. Is it coming back? Okay, no more questions. Thank you very much. So next is Leonidas Koussous and Christos newspaper. Leonidas Koussous will be presented, and the title is multivariable control chart for SPC combining PCA and radial representation plots. You're not sharing, right? Δεν έχω ξεκινήσει το sharing. Μισό λεπτό. Αν μου πείτε πώς το κάνουμε. Στο sharing. Share την οθόνη σου από το meeting. Πήγαινε στο meeting κάτω. Είναι που και ο Νίκος τώρα να μας το δείξει. Αν πρέπει να τους μέσα. Βλέπεις κάπου το meeting που είναι. Κύριε Δουκά.
To sort of no need to have
Yes. Αυτό.
Slide.
Το slide. Αυτό είναι το slide.
Ανέμερ slide. Εδώ. Αυτό το λέει ή χωρίς.
Ναι, ωραία, δεν το χρειάζεται. Έτσι το αφήνω, Ωραία, ωραία.
Dear guests, good evening. I'm Leonidas Koussous, and I'm going to present a new multivariate control chart for statistical process control, combining principal component analysis and radial visualization plots. The outline of the presentation, some brief words about PCA and multivariate statistical process control, motivation and state-of-the-art, radial visualizations, objective of research, an example that we will present, and brief conclusions. Principal component analysis, abbreviated PCA, is a multivariate technique which transforms a highly correlated data set into a new orthogonal reference system of uncorrelated variables, the principal components, which are linear combinations of the original variables. These principal components are directions of maximal variance. The transformed coordinates are termed PC scores. In multivariate statistical process control, we will refer to it as MSPC, has greatly benefited from the use of PCA, mainly because of three reasons. It reduces dimensionality, so makes the work easier to be done. It simplifies the calculation of critical and important multivariate statistics like hoteling t-squared, and PCA describes a model of the data, it models the data, thus it allows us to use other inference methods and derive statistics and residual analysis. The expression you see in the first equation is the hoteling t-squared statistic, which is very important in multivariate analysis, and this is the traditional formula to calculate it. As you can see, there is also a term in the middle, which is the covariance matrix, which has to be inverted. This is not always simple, but if we use PCA, then the equation gets another far more simplified form, as you can see in the second equation, far simpler to calculate. Of course, with this statistic, we have to calculate an upper control limit. Motivation and state-of-the-art. The use of PCA is undoubtedly widespread in the area of MSPC. Yet most of the existing MSPC methods use control charts that are either multivariate extensions of the univariate Shewhart control chart or other univariate or two-dimensional charts based on PCA or on statistical quantities like t-squared, which are applied or on or derived from PCA. So, inspired by the existence of multivariate visualization techniques already in use in other disciplines, such as exploratory data analysis and data mining, we resolved on attempting to use these techniques in the area of MSPC. The new approach we propose is MSPC control charts based on star coordinates projection, which is a multivariate radial visualization technique introduced in 2000. Radial visualizations arrange variables radially in a circular pattern. Star coordinates. It is a linear mapping that projects elements from the n-dimensional space to points on the plane. The variables of the n-dimensional space are represented as unit vectors arranged radially in equal angles around the perimeter of a circle. The axes representing these directions of the unit vectors are the dimensional axes. A multidimensional element xi is mapped on the plane of the star coordinates using the formula you see first. But the coordinates, the original coordinates, have to be normalized to lie in the range 0 to 1. This is critical. This projection can be thought of, as you can see in the graph, as the vector addition, as the vector sum of the axis vectors scaled by the value of each one variable. Star coordinates is not one-to-one mapping. This means that multiple n-dimensional elements may end up at the same position on the star coordinates plane. But if two multidimensional elements lie close together in the n-dimensional space, they will also be close by on the star coordinates plane. On the other hand, points that are far apart in the star coordinates plane will be also far apart in the n-dimensional space. Let's propose an MSPC procedure based on the combined use of star coordinate-based radial control charts and PCA. The aim is to use radial control charts not only to identify outlying observations, but only to determine the causes of abnormal behavior. The method will be presented in a stepwise manner through an example, and the application results will be evaluated by the degree the results agree with the modifications induced in the original data set that we will use. The data set that we will use for the example is from the book of Santos Fernandez, who created a library for the R programming language, and it's called bimetal data set. It consists of 5 measurements for 5 quality characteristics concerning brass and steel metal thermostats. It comprises 2 subsets. The metal one, which we will call the control set, which contains 28 observations which are in control and which will be used to set the limits for the process. Next, the bimetal 2 dataset is the phase 2 dataset, again a matrix of 28 observations, which will be used to test if they conform with the limits specified by the control set. We will call this second set the test set. We have modified this dataset as follows. We have removed from the control set 2 observations because it contained some extremal observations, and we have chosen samples 21 to 28 with respect to the variables CRV and HHS, where we introduced a stepwise shift of half sigma. The process. First of all, control set coordinates have to be standardized. Using the standard scores, we calculate the parameters of the PCA transformation. Next, using the calculated parameters, we calculate the principal component scores for both the test set and the control set. Then the next step is to decide on the number of principal components we are going to use for the rest of the analysis. There are many methods in the literature. We will use the cumulative explained variance plot, which is this one, and according to which we should probably use 4 principal components. We will not use 4, we will use 3. First of all, because 3 principal components already reassure that we have 87% of explained variance, and the second reason, which we will explain in a few moments. So we are going for the next step to use principal components 1, 2, and 3. Using these 3 first components, we will construct the first main radial control chart, as we call it, the MRCC. It is a star coordinate-based graph. It contains as dimensional axis the 3 principal components that we have selected, and on this plot we will project using the equations of the star coordinates projection. We will project the principal component scores for the control set and for the test set. Additionally, we will draw the convex hull polygons, which are used just as empirical reference regions and to facilitate comparison and visual inference. After that, we draw a standard deviation ellipse of specified confidence level. For this plot, we have used 95% of confidence level. The use of the standard deviational ellipse is critical because this acts as the primary control region. But is it legitimate to use a standard deviational ellipse? Yes, in most cases it is. If we assume that the initial multivariate data set follows the multivariate normal distribution, then under PCA and star coordinates transformations, which are both linear, normality is preserved. Therefore, the final coordinates on the plot are expected to be binormally distributed. So it's okay to use a standard deviational ellipse. On the plot, you can see the green control points, the blue test points that are in process, in control. The red points that are the outliers, they lie outside the control region, and another type of outliers, type 2, which is indicated by an inverted triangle, which are not outliers in the sense that they lie in or outside the standard deviational ellipse, but they are above the limit, the upper control limit set by the Hotelling t-squared test that we are using in parallel. So that's what we have done until now. We have produced the MRCC and we have detected a first group of outliers, which can be seen on the report. It's 14 outliers. Next, we are going to use the same input, the test set and the control set, but this time we're going to use principal components 3, 4, and 5. We'll explain why in a while. Again, we are creating a control chart, which is called the complementary radial control chart. This time we're using a confidence ellipse of 99%. Okay. Okay, this we have to do this because there might be outliers that are not visible in the space, in the coordinate space described by the first 3 principal components, but are visible to the complementary orthogonal subspace. Both graphs produce in total 15 outliers. These outliers will be combined. We will standardize these. These outliers with respect to the initial variables to produce the final plot. The final plot is the radial outliers plot. Again, it is based on star coordinates. We are using 5 classes, which are numbered according to the total shift. These variables are then arranged according to some metric, so that variables that exhibit the largest shifts are put together close by, and the effect becomes prominent. We have marked some observations. As you can see, these are observations 23 to 28, which have been those at which we have introduced the artificial shift. And the artificial shift concerned variables CRV and HHS, as has been detected successfully by the plot. Additionally, if we repeat all the process for the original unmodified data set, then the outliers show the bottom right picture, which is just an extract of what is present in our plot in the example. So the radial outliers plot has successfully detected also the original shifts. So this was a complete methodology. It has been seen that it is very effective when combining MRCC and CRCC together with Hotelling T-squared. The advantage of using radial visualization plots is that they are sensitive to the relation between the variables comprising the dataset. Future work will implement other techniques and improve the existing, and investigate under which circumstances failure might occur. Thank you.
Any questions, please? Let me see from our web if we have questions. Please. Yes, please. Can you more loudly? So. The seventh slide. Seventh slide. Yeah.
The seventh slide. Just a moment.
Next one.
The relation is not bijective. It's not one-to-one. That means 1 point from the n-dimensional space gets is projected to 1 point in the 2-dimensional space. But there might be multiple elements of the n-dimensional space that map on exactly the same point in the 2-dimensional space. So the relation is not one-to-one, it's many-to-one. Many elements of the n-dimensional space might end up in only one element in the 2-dimensional space on the plane. Yes. Yes. That's just a symbol. It's not 1 minus 1. It's just symbol. 1-to-1, 1-to-many. You're welcome.
Right, better 1-to-1. Seems like it. Any more questions?
How you imagine the second type of outliers usually appear in outliers type 2?
Yes, quite often. Quite often. These outliers mainly represent outliers that do not conform to the model described by the principal components. Normally, if the model is of good quality, the last principal components should only contain nearly noise. But in case that there are new events that were not present when the model was constructed, then these new events won't fit the model, and they will show up as very extreme values in the last principal components where there should be only noise mainly. So in these cases, it happens. And by using the second, the complementary radial control chart, we are able to catch these anomalies.
Any more questions, please? Thank you very much. Next out. Oh.
is by Venus Varela and Tony Claudio Estatico and Ioannis Zakaropoulos. The title of the study is Land-Level-Banach Regression in Statistical Learning.
Can you hear me? Okay, perfect.
Not sharing, please.
It looks like it's sharing.
Okay.
Okay.
Try to move on.
Okay.
Okay.
Good evening, everyone. So it's been a great session. Perfect. I'm Ioannis Zakaropoulos, and I'll introduce the Land-Weber-Banach iterative scheme, and we'll see an application in 2 variable selection problems. Because I was concentrated on the algorithmic implementation, and due to our limited time, I'll focus mainly on the results from this application. To begin with, I'll lay out the motivation and goal behind this application. I'll mention some mathematical background behind this method because most of it is described extensively in our paper. And last but not least, I'll describe my work, which was the algorithmic implementation, and we see the results by this application in 2 examples. So what is variable selection? It refers to the process of choosing important variables to include in a regression model, which helps to improve model performance and to avoid overfitting. So given a design matrix X and a response vector Y, we want to choose important columns of the design matrix to include in a model. We have 2 types of problems: the overdetermined problems, which may have a unique solution, and the underdetermined problems, which have either no or infinitely number of solutions. In general, we accept the sufficient solution as being the minimum norm solution. And our work is concentrated in the underdetermined case due to the fact that there are not many known methods that solve these kind of problems without applying reduction. So what is the Land-Weber iterative method? It's a basic method for solving least square problem iterative scheme. However, we won't try this method in Banach spaces. And this method was introduced for linear inverse problems in a continuous setting, which are generally ill-posed. So we will start with the assumption that we only have a delta level noisy version of the true data, and our initial guess is 0. So we will proceed as follows. So again, we have the basic iterative scheme of the Land-Weber method in Hilbert spaces, which is that. However, transitioning to Banach spaces, we see that this term is not correct, and we also have another problem with this abstraction. How do we solve those problems? We solve them using the duality map function, which allows us to associate an element of a Banach space beta with an element of its dual space, beta star. And we can think of this function as the minimization of a convex functional. So this is the duality map function according to the Asplan theorem, which is the subdifferential of the context functional. This one. And I need you to focus on this last line.
all those operations are linear, which means that this algorithm is really effective. So now let's move on to the algorithmic implementation. I mentioned again that all this is described extensively by Professor Statico, the expert of functional analysis, in our paper. So our first subroutine, it is the duality map function, which was described in the previous slide. We just have beta, some values which are used for the norm, and according to if beta is 0 or not, we define the result by application of the duality map function to that. So my work starts from this place. This algorithm uses the iterative scheme I described before. First, we initialize the rows of the design matrix, the columns, some values which are used in the duality map function, and our initial guess of the solution. So as we can see, with the inputs, we have the design matrix, the response vector, a max number of iterations, which we'll use to apply the iterative scheme max iteration number of times, and of course, the value for the P norm, which is used in the duality map function. So in line 4, there starts the iterative scheme. At first, we compute the residual. We use the duality map function to associate it with an element in the dual Banach space beta star. And of course, we use the iterative scheme to find the solution. So in the end of this algorithm, we have found the approximate solution of the least square problem. However, not all values of P, of the P norm right over here, produce the same results. So what we did is that we took an even partition of the interval 1, 2, and we applied the algorithm described in the previous slide for all those items of the regular partition. So we save all those solutions in a matrix, and we apply some statistics to identify the importance of its factors and to see how good the approximation to the theoretical solution are. So these statistics described by this function, we just test the null hypothesis for every factor and identify the important ones. So on to our case studies. The first one is about the SSD 6x10 data. We have this design matrix and this theoretical solution beta, which we can see is sparse. To be specific, the only non-zero values are in the 0th, 2nd, and 5th column. So the response vector y obtained by using the above simulated model is this one over here. So our goal is to use the iterative scheme described before to approximate that solution which satisfies the noise-free system y equals x dot beta. So here are the results of the application of the algorithm, which might look overwhelming at first. Let's draw attention to the highlighted parts. With green, we have the theoretical non-zero values of the solution. And with orange, pink, and purple, we have the greatest value of every solution produced by application of the algorithm for a certain value for the P norm, as can see right over here. We see two important things. The first one is that there is a common pattern derived from values of P equal to 3 and onward. This is that there is a match between the non-zero theoretical points of the solution and the greatest values of our solution. The second thing is that if we compare two solutions, and to be exact, if we compare a solution which was used for P equal to 2 and another one, for example, P equal to 1.4 or 1.5, we derive that values of P closer to 1 seem to be improving the sparsity of the solution. So of course, we need to use statistics to back all those assumptions up. So by using the F-test for P equal to 1.4, which was the one we selected because it was the best approximation to the theoretical solution, we derived that the three important factors resulting from this application are that B0, second, and fifth columns are the most important, which agrees with the literature and the theoretical value. And we can see that the response vector y obtained by the application of the Landweber iterative method is a really good approximation of the theoretical one. So the results of this case point is that the Landweber method in Banach spaces, which is the application of the algorithm for values of the p-norm different than 2, greatly improved the sparsity of the solution. The second one is that learning from the data, we saw that the best approximation of the solution was for the value of p equal to 1.4. And last but not least, it was that the Landweber iterative algorithm achieves a sufficient solution without the need of reduction. So our second case point is some real data, the Williams-Rabbit data, with that design matrix. Of course, I need to note here that there was a duplicate column which was removed from the data. This was the 13th column. And we have the original response vector y as follows. So again, we apply the Landweber method in this data, and this is what we get. Now, the terms highlighted with green have a different meaning. They are the columns that literature identifies as the most important columns. And again, we identify those two things we noted in the previous case point. That is that for values of p equal to 1.3 and onward, we see a match between the green parts highlighted and the two greatest value of the solutions. And the second one is, again, if we compare values of p closer to 2 and p closer to 1, we see that there is an improvement in sparsity again. So of course, again, we need to apply some statistics to back all those assumptions. And we again apply the F-test to identify important factors. And the results are that, again, for a fixed significance level of 0.1, columns 15 and 17 are the most important factors. And this, of course, agrees with the literature where factor x15, meaning the 15th column of the solution, is common in all approaches, and that the 17th one was detected in almost every approach. Regarding those data is again that the Landweber method Banach spaces, which is the method applied for p different than 2, slightly improved the sparsity compared to the method in Hilbert spaces, which is for p equal to 2. Again, by learning from data, we saw that the best approximation was for the value p equal to 1.4. And last but not least, the method works without application of reduction to the model. But this begs the question, how do we choose the better value and why did we choose p equal to 1.4 for those two examples? Of course, we need to use some measure, some norm or something to see which is the best approximation because there is no mathematical proof which says, okay, pick 1.4 for examples. This doesn't work. So we need to learn from the data, test, and choose the better value. Another thing is, which is really notable, that in theory, how work goes on conjugate close to with
Hello, everyone. Okay. What I'm going to present to you right now is the Golub-Cahan regression for variable selection statistical modeling. First things first, we're going to have an introduction where we introduce the problem and why are we actually using the Golub-Cahan regression. Then we're going to see a brief description of it. And lastly, we're going to see some examples. Now, what we want to do is to actually solve a linear model. The linear model needs to have a design matrix to be overdetermined, meaning that the number of rows need to be more than the number of columns, or let's say the observation more than the number of factors. Now, anyone could actually use regularization technique, but we actually want to avoid this because it is computationally expensive, and there's an obstacle that we have to select the regularization parameter. Now it has been proved that actually regularization is not always needed. This has been proved in some models of machine learning, and also, according to the condition of the dataset, regularization is not actually needed. For this reason, we are suggesting the Golub-Cahan regression, which is a direct method. It reduces the model. It is a Krylov, let's say, based method, meaning that the reduced model is going to be a really good approximation for the original one. And it is based only on MVPs and IPs, meaning matrix vector products and unit products. The base of the whole regression is the Golub-Cahan bidiagonalization, which is a factorization technique. It takes as an input an overdetermined matrix, and it produces three matrices, two orthogonal and one bidiagonal. As we can see here, the bidiagonal matrix consists of two blocks. This shows you can see here the expression of varies. Also, we can see why it is a direct method and why is it a Krylov-based method. Now, what we actually do is that, let's say we have a linear model with an overdetermined matrix, and we apply the bidiagonalization technique onto the design matrix. We get the reduced model and eventually end up solving just a bidiagonal system, and that is all. This is the pseudo algorithm, let's say, which again consists of only matrix vector products. And now for the further improvements, the first things that we do is to initialize the starting vector instead of having a random one. The initialization depends on the design matrix and the response. By doing so, we have a more informed starting point. And the second one, and the most important one, is that we do reorthogonalization. The reason we do so is that because two orthogonal matrices tend to lose their orthogonality. The thing is that we only use reorthogonalization on the columns of V. Now this is once again the algorithm for reorthogonalization. And as you can see here, even this algorithm consists once again only out of MVPs and IPs. And one thing I would like to note here is that even though it says two-step reorthogonalization, actually only one is needed, and the second orthogonalization is like a pillow. Let's see an illustrative example. Let's say that we have a matrix 6 × 5 dimensions, where the columns come from the normal distribution with mean 0 and variance 1. And we create a linear model. Let's say that we want the first factor and the second pattern to be important, number 8 and number 3. Then we create the noise and we get the response. Now we perform the Golub-Cahan regression onto the design matrix. This is the result that we get. And as we can see here, we get the B1, which is the upper block of the matrix. This is a 5 × 5 matrix. And eventually, we end up solving just a bidiagonal system. This is the result, the coefficient that we get, the estimation. A really good approximation we're actually going to do is just run an F-test. And the result, as you can see with the blue color, estimated model, is a really good, once again, approximation for the original one. Now for the real examples, what we have actually done is that we have taken from the internet real data sets, and we just create linear models. In order to check that the results are correct, what we have done is we have run two other methods. The one is the classical least square solution for overdetermined problems, and the second one is the skinny SVD method, which is once again a direct method. The result that we get is that indeed the skinny GK regression identifies the same statistically significant features, and the same coefficients are the other two methods. Now for the first example, we have the glass identification dataset, which is a 214 times 10 dataset. We choose, let's say, a response, which is, for this example, is the aluminum, the SQRT of aluminum, and then the other 9 remaining features construct a design matrix. What we get for the significance level of 0.01 is that eventually this response is affected only by 7 features. Next, we take another dataset, Turkish music emotion, that has 400 instances and 51 features. This one, for this one, we take as a response, let's say MFCC mean 1 OK, and the other 50 create the design matrix. Now, for this response, we have found that it is only affected by 50 features. The third one is a 569 instances and 31 features. It is the breast cancer Wisconsin diagnostic. And this one, let's say we take the variable smoothness 3, constructed, the design matrix is constructed by the other 30 features, and we only find that this response is affected by 13 features. Next, we have the wine quality. 97 and 12 features. We take for the wine quality, let's say, the variable density, and we have found that it is only affected by 9 features. And lastly, what we have is the dataset Magic Gamma Telescope. This one dataset consists of 19,020 instances and 11 features. Once again, we take the SQRT of the variable so as to have a linear model. And we see that this variable is affected by 8 features. And now to conclude the whole presentation, the main advantages of column graph regression is that it avoids the additional cost of regularization. Since it only uses MPPs and IPs, it's computationally effective, efficient, it is stable and accurate. It reduces, as we have seen, the dimensionality of the model. And because of the real experiments, we see that indeed it has an excellent behavior for models with all thin matrices. And lastly, it, of course, identifies correctly the important factors of the real data set, of the real models, which is what we actually wanted in the first place. Now, for future work, we want to examine even more data sets, and especially data sets that actually don't need regularization in order to see how it behaves. We want also to compare it with even more methods. And lastly, why not try to use parallel processing to use it into larger data sets? These are the references, and thank you very much.
Please, any questions, please? Are there any questions that we see in our website? Okay, we don't have any questions on the website. Well, can you tell us, except the next experience, as we see, what is about the computational time of research?
The computationality is, with the reorganization, is like is a n square plus n, how is it called? In 3. Okay, it's that one, but if we, try parallel processing, maybe we can actually indeed reduce the computationality. This is actually for the future work. Yes, in order to have a make it run better.
That you can use with personal computers.
Yes, exactly.
Thank you. For that research, you need to hire for this.
Yes, yes, indeed.
Thank you. Our next topic is by Ioannis Arkoudis, Georgios Patriaskas, Europa, Mr. Join. The topic will be from Ioannis Arkoudis, please.
Sí, meglio περισσότερο. Όχι, όχι, πιο κάτω. Που συνδετιζέται λοιπόν. Ωραία, το πάρω. Ωραία. Ας το πάρουμε και θα μας είμαστε. Ωραία. Το έχουμε τώρα.
Capabilities MFS for mixed electromagnetic scattering problems in chiral media for Lipschitz domains. Please, Mr. Arkoudis, to have 10 minutes.
Hello, sorry for the delay. The work we will present basically describes the application of the method fundamental solutions for a mixed electromagnetic scattering problem in chiral media for Lipschitz domains. We will start with a very brief introduction to chirality and some of its applications. The
My name is George Tathakis. I'm going to present the application of virtual reality and augmented reality in military training. VR and AR offer safe environments for training, allowing soldiers to develop skills without real-world risks and the ability to practice complex scenarios that would be unsafe or impractical in a real-life combat situation. For VR components, we need hardware, use head-mounted displays, motion sensors, and haptic feedback to fully immerse soldiers in the training. We need the software, the use of advanced algorithms for real-time simulations, handling environmental physics and integrated data to create realistic experience. And we need the content design, collaboration between military experts and developers to ensure the scenarios are both relevant and highly realistic. And the impact training in dangerous scenarios like combat can now be done in a controlled, risk-free environment. So VR and AR enable the rapid creation of diverse, realistic training environments, and it is cost-effective, reducing the need for travel and extensive logistics. Emphasize the ability to replicate various combat conditions and point out how simulation cover both urban and rural battlefields. The advantages stress the importance of repeated practice in high-stress scenarios to build resilience and focus on the personalization of training, adapting to individual needs for more effective learning. So, immersive combat scenarios in VR replicate real battlefield scenarios, and this allows soldiers to practice making quick, high-stress decisions similar to what they would face in the real combat situation. VR provides a real-time tracking of performance with instant feedback. Through this simulation, soldiers experience diverse combat conditions that help improve reaction times and adaptability. And the training can be tailored to meet specific mission needs, and soldiers can practice in scenarios that reflect their unique combat requirements, increasing their cognitive flexibility and ability. And control environments for practicing coping strategies, reduce stress management. So augmented reality in military training. Augmented reality overlays critical information like enemy positions or terrain data directly onto the real-world environment. This helps soldiers make better decisions in real time. AR creates safe and highly realistic environments for soldiers to practice complex tasks, and this allows them to build their skills while minimizing the risks associated with live training. AR is also being used to simulate medical procedures and provide step-by-step guidance for equipment repairs. And in shared AR environments, soldiers can collaborate more efficiently. AR helps improve communication and coordination between team members, which is crucial for the success of military operations. Augmented reality helps soldiers make quicker, more informed decisions in high-risk situations by overlaying real-time data into their field of vision. Also plays a significant role in equipment management, providing digital step-by-step instruction for repairs and maintenance tasks. And In certain AR environments, soldiers work together more effectively by having access to the same real-time information. So virtual reality and augmented reality create immersive environments that replicate real battle conditions. And these simulations support tactical decision-making with AR overlaying crucial real-world tactical data. Augmented reality tactical decision games focus on improving strategic thinking and flexibility under pressure, and these games enhance teamwork and cognitive abilities, helping soldiers practice making decisions in a dynamic environment. VR and AR enable multiple users to train together in shared virtual or augmented environments, and this collaborative training fosters communication and teamwork among soldiers, allowing them to coordinate their action in safe settings. So improving tactical decision making means that augmented reality allows combat medics to simulate medical emergencies, providing them with opportunities to practice critical decision making in real time. And AR technology overlays vital patient's data, such as injury assessments and vital signs, directly into the medic's field of view. Augmented reality provides interactive 3D visualizations of medical devices, allowing medics to gain hands-on experience in a safe and controlled virtual environment. AR technology overlays step-by-step instruction directly onto medical devices, ensuring that critical procedures are executed precisely, even in stressful conditions. And using AR enables repetitive simulation of various medical scenarios without the wear and tear associated with physical equipment. That's why it is cost-effective. Virtual reality creates immersive environments that closely mimic real-world scenarios, significantly enhancing decision-making abilities for soldiers. Research indicates that VR improves self-efficacy and retention of knowledge, allowing soldiers to practice their skills safely in highly realistic settings. And VR facilitates training on complex processes involving precision equipment management. Augmented reality significantly enhances situational awareness of overlaying tactical insights and critical data directly into soldiers' fields of view. Shared augmented environments foster collaboration and coordination among soldiers, and the overall impact is that the integration of virtual reality and augmented reality technologies significantly boosts tactical decision-making, equipment handling, and overall military preparedness. This is literature review work. So in the future, we would like to investigate how the use of AR can enhance soldiers' leadership training by providing realistic simulation and real-time feedback. And we're planning to use experimental studies with soldiers who will be trained in leadership scenarios with AR. So the effectiveness of the training will be assessed through questionnaires and performance analysis. Thank you for your attention.
Thank you, George. Yes, please.
I would like to ask if you are using just controllers for the computer regulation, let's say something that seems like a weapon, or if the users actually like run their platform, something like that.
we may use in our future work, but this was a literature review work, so in the future we may use.
So you made any simulations?
Not yet.
So this is the first.
Yes.
The first
Yes.
Are there any questions?
Thank you.
Thank you very much. The last talk is by Ioannis Pekapos, Nicholas Lucas, and Chris Detection and prevention of phishing attacks. Augmented reality education is very important nowadays, but cyber attack is also. So, Professor Lucas, you have 5 minutes.
5 minutes, okay. No problem. Okay, so it should be visible now. So this is some new research starting just very recently about detecting phishing websites. It's by a master's student in academy, and of course, participation. So, phishing, I will go quickly through this. The things that you know, because phishing is an attempt to elicit personal information or information such as bank account details and credit cards from unsuspecting individuals with the purpose of obtaining some kind of financial gain. The usual way in this work is they try to disseminate a link that looks like it's something legitimate, but it's not legitimate. It has an purpose underneath, and trick the potential victim into clicking on that link. So the detection is based on on analyzing the URL or the address that is sent to the victims before they have a chance to click it. So to draw conclusions to see if what is there is real or not. So starting from a scheme that was presented a few years ago that analyzes URLs, we see that there is a necessity for similarity-based detection, as we will see. It's not just looking at the address is not enough to create to make a decision. So machine learning and other techniques are we hope we are able to employ machine learning and other techniques in order to achieve better classification results. So typical phishing attacks have many ways of expressing themselves. itself, we will focus, as I said, on analyzing links and web pages and deriving from them indicators that will eventually allow us to see if this is a phishing page or not. The bad thing is that many users, even experienced ones, most of the time, ignore all the cues that exist, visual cues. Sometimes it's really easy to spot phishing page. And but there exist also counterfeit websites that are unbelievably realistic. So they can trick even the most suspicious user into clicking. Into clicking onto the link and falling victim to the phishing attack. So standard security indicators are not sufficient, as we observed, and that's why we are looking at alternative approaches to detect such attacks. So phishing is a growing problem. It has been going on for ages, even though people are talking about it every so often. We hear a person very close to us falling victim to a phishing attack. One of the common approaches is the creation of a website that looks similar to a website that the potential victim might like to visit. Social engineering can be used in this direction in order to pick the correct victims and also select critical to an online bank or to a financial institution to capture passwords, social security numbers, etc. So the victim may not identify the malicious website until it is too late and all their confidential information has been disclosed. There exist also other ways of blocking these kinds of phishing attacks. Email level approach, so filters, especially by big providers, are employed to filter out the phishing messages. However, I'm sure that most of you have experienced email that you are really looking forward to receiving being blocked by a phishing filter and never being received by you. So even in that case, what is happening can have many false positives that can also have detrimental effects. Instead of having a phishing attack, you have a denial of service attack and created by your provider. So, okay, they prevent a lot of spam emails and decrease the number of email-based phishing attacks, but they have the drawbacks. Also, some browsers will tell if it's suspected phishing, and there exist some add-ins for the browsers that will also tell you that. Blacklists or whitelists can be used in order to block such kind of malicious website and malicious web email messages, but again, these create many false positives that very commonly create more trouble than they prevent in our school, because we have all these young students doing everything they want on the internet. We constantly get blocked. We are losing many and very important messages. So also blacklists will not work when the hackers use some techniques that we see, that we will see later on, that cover the way they have attempted the attack. Another way is heuristics. So by rules that have no proof and are arbitrary, we're trying to filter out what might be necessary, but because all these are heuristic and because they're intuitive and arbitrary, also we have many false positives. User polling, so by collecting the experience of the victims, we try to see which websites are dangerous or malicious and keep other users from falling victims to the same scam. And also third-party certification authorities and reputation services, similar to the blacklists, but more formal. Again, with the drawbacks. If we summarize the shortcomings or and no fake interface or and fool them, and the response time is relatively fast. Heuristics, of course, produce a lot of false positives and maybe fall into zero-day attacks. In general, all methods seem to have drawbacks, and that's why we believe that trying to employ multiple indicators and some kind of machine learning will enhance our ability to correctly detect phishing without going into without blocking ourselves out of history. So the URL, the addresses that we see, or the links that we click on web pages in general have this kind of syntax. From this syntax, the parts in between the smaller than and greater than signs are in general commands and are not visible, while the text in the middle, the anchor text, is visible and represents what we see and click on the page. Phishers will try to exploit the functionality of these commands so that they hide what they have done, the direction, and trick us into clicking on the link. One very simple trick is to show one address and direct on another address. So you see inside the less than greater than there is the bogus address, but in between, in the anchor text, there is a legitimate address. All the addresses in this presentation are fake because they don't work, so there's no point trying to access them. The other way to do that is by a cross-site scripting attacks, which in which case the attackers exploit the capability of a server to redirect you to some other server, and if this is not properly protected, this server could be anywhere. So an unsuspecting web server might redirect you to a web server operated by the attacker. Again, without seeing anything, can be through target can be hidden in a innocent-looking message like "click here to get the file." Also, the use of numerical IP addresses in conjunction with inserting some text in the overall address that will seem logical to the user and legitimate to click on. For example, you see here, there is this www.film.com, but in reality, this will not go to that website. It does not exist again, but it will take the user to this numerical IP address, which of course contains the malicious code. The misleading encoding, web browsers, as you may have experienced, have several ways of encoding the information. Sometimes we see these very ugly hexadecimal representations of the characters instead of text. This especially happens in languages like Greek that's containing Greek characters. And so, even though the user might believe that connecting to their bank. These numerical characters that represent characters that lead to the features operated website will lead us into the tab. Similarly, with the @ sign in the visible link, okay, we see that we are going to the task shop, but in reality we are not, because that sign is redirecting us to some other address. Finally, there is a neutral visible information, so there is the message says click here to confirm your account, and the address, if someone goes and look at it, looks similar, but it's not the same. It's payfriend.com, maybe the legitimate address, but payfriend-cgi is some other address that is owned by the attacker. So, way to analyze a website or a link in order to decide if it's a phishing or not is to extract the DNS name from the visual link, extract the DNS names for the actual links. We saw that they exist in different parts of the address. Address similarity via the phishing indicator. So we see if this address is similar to some legitimate address, or one of them is the legitimate, probably the visual, and the other one, the actual, is slightly different from it. This is used as a phishing indicator. Check for dotted decimal, the one we saw with numbers, instead of addresses, is directly used on the DNS. This question mark that you see, I'm sorry, in my screen they come up as arrows. Here I don't know why they became like that. So this is also a possible phishing indicator without being certain. While the similar, slightly dissimilar address, facebook.com and facebookm.com, is a clear tell that it's phishing. The dotted decimal might be legitimate. So also the next step is to check the actual link or visual link that is encoded. So decode the links and check via the first 4 steps. And then go and check the actual DNS of the link domain. So checking the DNS can reveal if it belongs, if the site that we use belongs to a legitimate owner or some kind of fisher. Continuing on the workflow, check for blacklist entries, whitelist entries, and find similarity with manually entered addresses. This is the point where we leave the localized analysis and we go into some kind of global analysis that needs also historical data. So we can find similarity between manually entered addresses from the user themselves in the past and addresses in the links. So this is an indicator that someone knows we are accessing this address and is giving it to us as a bait. If they match exactly, so it's a link that is clicked by the user has entered it manually in the past, is a clear sign that we are safe. But if there are small differences, this could be phishing or could be normal, because legitimate sites, of course, never have exactly the same address. They have a lot of content, they have a lot of variations as well. And then visual analysis. So extract images and store images. So we need databases of legitimate sites, databases of phishing sites. Search in stored images of legitimate websites and compare trusted store link with visual and actual links. So essentially the images, if the address that is given is so much obfuscated that it cannot be recognized, it cannot be matched to a legitimate address, then by retrieving from the database, we can see from the images what the intended legitimate address is. Again, if it matches exactly, is where safety, and if there are differences, maybe there is a phishing list. And the biggest, of course, would be to compare the look of the entire page. So consider the entire page as an image, and then assess the similarity of the page appearance with our legitimate page appearance. And if we have a match, exact is not a very good word here, because it won't be exactly the same, but it will have the same look. A human would say, okay, this is the same website. And if there are differences, we assess the phishing list. So as you can understand, the last part, the last two slides have started diverging from what can be done via normal programs, normal algorithms, and this is where machine learning comes in. And there is a class of image recognition algorithms that are called content-based image retrieval algorithms that use the image itself rather than using any metadata or any extracted features that we don't know if they are sufficient or not, or if there are too many, in order to assess similarity. It has been shown in other applications that it has very good capabilities of saying what a human would say. This picture and this picture are from the same artist because they have the same look and feel. So these kind of algorithms have been shown to have this capability. They are related in the literature with hashing. So it's called deep hashing sometimes, or machine learning hashing, or learning hashing. And they are vectorizing features. Essentially, they are extracting features, selecting the best ones depending on the training they have, and then they can do very fast classification. The training phase is very slow, but the application is really fast. That's why it's associated with hashing. It produces a short binary code from a large image or a collection of images. And because of its ability to select the required feature, it's also doing dimensionality reduction. That's my 5 minutes. So I will go very fast. As I said, they can do image retrieval. So we tell them we're looking for the image of a car, and we'll pick out of the data set the cars. I'm looking for a flower, the flowers. Also similarity. Are these two pictures the same flower? Nowhere is about scaling, rotations, and stuff. And behind them, they have convolutional neural networks as their inside engine. The optimization in this case is single stage. Training applied directly with images, no need to extract features. So if we attempted any other kind of training, we would have first to select the features, train, see if they're good, go select other features. Well, in this case, the features are selected by the algorithms. So it is a hashing, a new new concept of hashing, I would call it, and it is we're going to produce good results here. There are several algorithms. They define a classification objective function that gives them the capability, and a pairwise similarity objective function that gives them the similarity assessment capability, so they can do both things, and then we can balance what we want more. Apart from using it for images, further ideas include using it to compare with texts, because, as we said, the text even can be very cunning and hide very well the fact that they're not real. Compare page texts and assess again similarity to other phishing pages. And of course, since we listed a lot of indicators as I was describing the features, consider all these indicators together and produce a final decision. So I think we have concluded everything. Just to say that there are lots of database, because the first thing that worked us as well in this research, there are lots of databases with phishing emailing website examples. So this kind of training will have enough data. Of course, the problem of processing power is as at present, and Colab is the best friend in this case. Thank you very much.
Thank you very much for your presentation. What about any metrics which can be used to assess the risk of different attacks and intrusions? Because it usually is very important questions. How you can calculate, assess quantitative metrics to manage application of countermeasures.
So here the aim is the detection and warning, so an early warning sign. All these features that I have outlined are quantitative, so they are measurable. The machine learning algorithm is going to help us assess relatively large vector of features that we need to take into consideration to decide if it's phishing or not. Until all this is concluded, I cannot give you any numbers of the success rate, but hopefully it will be quite good.
I think the risk-oriented approach will be applied, similar to most effectivity analysis and any other to better understand which risk we have in the cases of such.
Yes, I agree with that.
So, the question, so we can use it as CNN.
It's learning hashing, so the CNN is used essentially to design this hashing.
Set is on the physical and other attacks.
And from the point of view of attacks, it's only for phishing so far. But in other applications, also we had presented yesterday another paper that is using the same kind of algorithms for a different kind of application.
Thank you very much.
Thank you. Maybe you want to come here close.
Yes. Thank you for today. We had our session offline. It was a lot of papers, and I can say that present all of them. We have received about half an hour. It was a small delay, but we had a successful session, and I have to thank you for your participation, of course, online and offline.
and we wish next year to make our conference offline and online, but in 3 days, all days. So it was very nice task for next year. Thank you very much for you. Thank you very much all the people that was in the parallel session also. And now we'll have a small coffee break to finish our session. Thank you. Next meeting is tomorrow morning for some sessions and for round table and to close our conferences. Thank you.
Clean.